What is going on, everyone? Welcome back to another video. In this video, I am proud and happy to announce that I am finally done with the beginner version of the Python course. So I plan on making an intermediate and maybe even an advanced version of this Python course, but that's for the future. As for right now, I have finally finished a good amount of videos to where I can post the beginner friendly full Python course. So linked in the description down below, you'll see the playlist for all the videos in this playlist. And from those videos, you can get the full code for whichever video you're watching at the moment. And from there, you'll be able to copy it and use it to your own liking. And in the future, I will plan on making more videos, like I said, but not just with Python, but also with Java, C++, and different programming concepts and computer science concepts. But as for right now, it's going to be just Python, and we'll see where the future takes us. And I hope you guys enjoy this video. But before I start the full course, I would just want to point out that I did not edit out the parts where I do the intro and the outro for each video, so I apologize for that. I have other videos on my channel about other programming languages. I even posted a full course. I think it's a 1 hour course on HTML, and I'm starting to learn a little bit more about JavaScript and CSS. So there's more content coming out on that. But I did spend a fair amount of time. It took me months to complete this full playlist and put everything together and edit everything and all of that. And now this full course is finally ready. So I would really appreciate it if you guys would take the time to like and subscribe and leave a comment down below and let me know what more you want to see, what more of you want to see, whether it's more Python or other programming languages or even any other computer science concepts. Like maybe I'm thinking of doing some discrete math videos so I can torture myself a little bit. But yeah, without further ado, let's get started with the full Python course. Hello everyone. Today I'll be showing you guys how to download and run Python, and also I'll be giving you guys a brief introduction about Python as a programming language. So as you guys know, Python is a programming language and it has many benefits. You might be wondering, why Python? Well, there are many benefits of learning Python, some of which are earning potential. Python is the second highest paid computer language according to Indeed. It's pretty easy to make money with any kind of programming language as long as you master it, and the ease of comprehension. It's one of the top benefits of Python because it's really fun and easy to use. You can basically learn the syntax pretty easily, and if you're not familiar with the word syntax, it basically means kind of like the grammar of a programming language. So the syntax or the grammar for Python is very, very, very simple. It doesn't take much, unlike some other languages like maybe Java or C++ or uh, SQL. You know, those are kind of complicated or can be a little weird. Flexibility, it's really fun, but it's also flexible. You can do a lot with it, you can learn a lot of things with it, and in the next slide you'll see some more examples of what you could do with Python. Next is installation of Python. So first, in order to install Python, you have to install the programming language Python first, which you could do that from this website, which I'll have in the description, of course. So from here, you'll go to, if you have Linux or Unix or Mac or whatever, you'll choose your operating system from here, and then you'll click on download Python 3.11.3, which is the latest version at this time. So after you download it, you basically want to download an IDE, which stands for Integrated Development Environment. And that's basically just a place where you can write all your code. As you can see here, it's kind of like this, instead of just writing it in the terminal or somewhere that's can be very difficult to understand for beginners especially. So here you go to the download screen and you press on download, and it's community download, and here it starts downloading. So after you click on it, this window is going to pop up, and I already have it downloaded, so I'll just click on upgrade now. So you're going to want to click on next, and I already have it installed, so I'll just uninstall it and reinstall it with you guys to show you how it's done. Next. Yes, I want a desktop shortcut, and that's all we need for now. Install. And here you can see the Python setup was successful after I clicked on the Python that we downloaded, so basically just installed by itself. So after it finishes, you're going to want to click on run and finish, and then it'll automatically start the application. I'm going to click on do not import settings, but you can choose whichever one you want. And then welcome to PyCharm. So you can create all your programs inside of a project. So I'm going to click on new project, and then here is the location of where it's going to be stored, and that's all I'm going to want right now. Create. Okay, so we don't need all of this. I ain't reading all of that. So here you can see the project main.py is your Python file, and each Python file is one program. So here you could delete this one, delete, and then you can just click on the Python project that you want to, or the directory. This is a directory, this is a project. So basically here I'm going to create my new program inside of the project. It's called Python project. That's what the project is called. So here you're going to click on new, and then Python file, and then basically you name it whatever you want. Oh, sorry. Click enter, and then it starts off here. So you can write your code here, and that's pretty much it. But this is a bit too small, so I'm gonna want to change the settings. So here you click on IDE and project settings, and then you go to editor, font, and then you can change the font. I don't really have a problem with the font, but you can change the size of the font, which I do have a problem with, so let's go with 32 for now. Yeah, that seems good enough. Apply and OK, and then yeah, that's much better. And then you can write basically just a simple program, print hello world, and then to run it you can either press shift F10, or you could just click on this right here, run main, and I already have error. Hold on. Okay, so from here I'm not sure what really happened with the error earlier, but I fixed it, and here basically you have the coding screen, and here you can write a simple program like we said, hello world, shift F10, and it just prints it out right here. And you can also, if you don't like this, you can also change the font and the color scheme and everything here through the settings. So you go to settings, and then editor, color scheme, yeah, and then you go to console colors, console font, or colors, and then you can change the font to whatever you want, or you can change the colors to whatever you want. So for the standard output, you're going to want to change it to whatever color you want. I can make it green. I think this is good. I like that color. And then you just click on apply and OK, and there you go, hello world in green. So there you have it. This is my first Python video. I'll be doing many more and adding them to one playlist. Feel free to subscribe and like this video if you enjoyed it or if you found it helpful at all, and tune in next time where I'll be going into data types, and each video I'll be going in more and more in depth into Python programming, and I'll be sharing my knowledge with you guys as I learn more, since I am a computer science student and I'm in my third year and I'm trying to share my knowledge as I receive it. So thank you for tuning in and have a great day. Hey everyone, and welcome back to another video. Today's video will be about variables and multiple assignments in Python. I hope you enjoy, and without further ado, let's get started. Okay, so first of all, we have the string data type. So for the string data type, string is basically just a word, and I'll show you an example here. So basically you can type fname. This is how you declare a variable. So fname equals to, let's say, David. So your first name is David. You can put the string in between single quotes, or you can put it in between double quotes. Both work. And then you can do lname. Last name is, let's say, Smith, maybe. So here we have two variables, fname and lname. Fname is David, which is first name. Your first name is David. Your last name is Smith. So you can do a couple things with this. You can say, you can print fname. Sorry. You can print fname, and that'll just print David. You can also print lname, which will print David and also Smith. Or sorry, this will, if you turn this into a comment, it'll only print Smith. So okay, you can also do another thing, which is you can put them together. So basically you can say print fname plus lname. But you see, if I do this, you're gonna there's not gonna be any space between them, and that's a problem. Let me turn these into comments first. So you're gonna run into this problem, right? So this can be fixed in two ways. First way is you can insert a space between them, like that. It doesn't really matter, these little spaces between the plus sign, but I just like to do it because I have like OCD. So you can fix it like that, or you can do it in a much simpler way, which I prefer at times, which is you just put a comma. And then you can do this in Python. Actually, you can't do it in many other programming languages, but if you put a comma, you don't have to put a space, but again, because OCD, I put the space and then it just puts a space for you. Okay, so you can also do another type of variable, which is integers. So for the integer data type, you can do some things like, let's say, age equals to, I'm 20 years old, so 20. And then you can print age 20. You can also increment the age plus 1, then print the age. Oh, sorry, you gotta plus equals 1. Print the age, that's 21. You can also do something. You can print all of them. You can print like David Smith, you are 20 years old, like as such, but I'll show you a common mistake as well. Hello, fname, lname, and then print you are age years old. So if I print this, if I run this program, I'm gonna get an error, and I'll show you why. Okay, I didn't get an error, but but if you use the plus sign, you will get an error. And why is that? It's because this is an integer and you're trying to place it in a string. So what you need to do is typecasting. I'll get into typecasting a little more in another video, but basically all you need to do is just turn this string into, or sorry, turn this integer into a string. And there you go. There are also some other data types such as float. So for float, float is basically just an integer with a decimal. So an example of a float would be like your height maybe. Height equals to let's say 180.25 centimeters. So print height. Sorry. Let me turn this into a comment. So your height is 180.25 centimeters. And again, if you want to print it into a sentence, you basically type your height is height plus centimeters tall. So again, if I run this, I'm gonna get an error. So you fix it by typecasting str. You run it again, and it's right. It's okay. It's fine. There's also one more, which is the Boolean data type. There are many more actually, but these are just the main ones that we use. So Boolean data type is basically just true and false. So for example, are you alive? You can set it to true, or you can set it to false. So basically you can say print are you alive? And then you can print alive. Are you alive? False, I'm dead. Or you can set it to true, and then you'll have, are you alive? True, I'm alive. I'm alive but I'm dead. And there's actually one more thing I want to show you guys, which is something called multiple assignment. Multiple assignment is basically when you have a couple variables with the same assignment, and you just, instead of doing it more than once, you just added it in one line of code. So basically, you can do it in two ways, right? You can do, for example, okay, so you could do like, let's say, cbum equals to Ronaldo equals to say Messi equals to a string which is the best. And just for the sake of it, let's also add Ronnie Coleman. Okay, so basically if I print cbum the best. We turn this into a comment. Okay, also if you print Ronaldo, also the best. I'm not really into football, but you get the idea. So this is basically I'm basically assigning Sebum, Ronaldo, Ronnie Coleman, and Messi. All of them I'm assigning the string this string, which is the best, to all these variables. So later on, when I use any of these variables, they're all gonna have the same value, which is the best. And then there's also another type of multiple assignment you can use, which is, say, name, age, male, let's say for gender, and then you can assign each one of these variables. This is one variable, this is another, and this is another. You can assign them all values on one line. So basically, for name, my name is Yusuf. For age, I am 20 years old. And for male, I am true. I am a male. And then if you print name, my name is Yusuf. If you print age, I'm 20 years old. And then if you print male or not, true, I am a male. So there you have it. I hope you understood. Basically, like a small introduction about variables, assignments, and multiple assignments. So again, just for conclusion, you have the f name and l name. These are the string variables. You can choose any name for your variables, any name at all, and it could be capital or lowercase, doesn't really matter. And then if it's a string, you put it in between single or double quotes. If it's an integer, you don't need any quotes. If you want to increment or decrement, you use the plus, equals, or minus equals, and then 1 or however much you want to increase by. And if you want to use an integer in the middle of a string, you're gonna have to either put it in between. Let me show you one more time, just to make sure you understand. You basically have to put it either in between. If you're gonna put it in between plus signs, you're gonna have to use type casting, which is turning the integer into a string, or you could also use commas, and it'll still work. Oh, sorry, I gotta. Sorry. Yeah, so it'll still work. I just had these commented out, but as you can see, it still works. So I hope you guys understood, and I hope you enjoyed. If you did, please like and subscribe for more videos, and let me know in the comments what other programming languages you would like to see and what other topics you would like to see. I'm gonna keep moving forward with more topics, and I hope you guys enjoy. Hello and welcome back to yet another video about string methods in Python. So there are a couple methods we could use for each string variable in Python, and today I'm going to be showing you some of the main ones that are mostly used. So first of all, to get started, let's declare a variable. So let's say name equals to my name. I can't spell today. Okay, so the first one is going to be about finding the length of this variable. So if you don't feel like counting all the letters, you can just use print len, which stands for length, and then you pass in your variable. You run the code and you get 6 because there are 6 letters in my name. And then you also have another method, which is find, which is like you basically use it to find a letter inside the string variable. So for example, let me show you an example. I'm not good at explaining things properly sometimes. So print name dot find, and then you pass in, let's say for example, S, and then you run the code, and then it's in the third one. So you start from 0, 1, 2, 3. So it's in the third space. So if you say F, it'll be 5 because it starts from 0, 1, 2, 3, 4, 5. Computers always start from 0, so even though there are 6, the last letter would be 5 because it starts at 0, not 1. And then turn this into a comment. And then you also have another method, which is the capitalize method, which is basically it capitalizes the first letter of the string. So print name dot capitalize, and then you run the code, and as you can see it's capitalized already, but if I made it lowercase, then you run it and it's still capitalized. If you turn this into a comment, you run it, print name, it's lowercase, but if you capitalize it first, or if you print it here, it's gonna, so first it's gonna be capitalized and then lowercase, as you can see here. And then the next method is going to be uppercase. So basically it prints the whole thing in uppercase, name.upper, and it prints the whole thing in uppercase. That's pretty self-explanatory. This next one is very much the same, lowercase. So basically it'll print the whole thing in lowercase. Let me just change this to capital, and as you can see it'll still be lowercase. And then the next method is digit. So it checks if the string is a digit or not, because as you know, you can have a string that's a digit. You can't perform any mathematical operations on it, but it'll still be a digit. Like you can make anything. Like let's say age equals to 20. See, this is a string and it's digits. So if you print, let's say here, print name dot is digit, it'll be false. But if you put age, it'll be true. And then the next one is alpha. So if it checks if the string consists of alphabets only. And as you can see, it's true. But then if you put age, it'll be false. We'll turn these into comments. This one too. Okay, so for the next one, we have name.count. So basically it counts how many times a character is in the string. So for example, print name.count, and then you can pass in whatever you want. In our case, we're going to use y. So there's one y in my name. So if you put 4 y's, you run it again, you'll get 4. So for the next one, we're gonna do replacing. So you can put print name dot replace, and then you have to, in here you have to pass in two variables, or two characters, sorry. So the first thing you want to replace, let's say, is O, and then you want to replace it with a U, or you can even replace it with more than one. Like let's say another. You can just say like literally anything, okay? And then you run it, and then that's what it'll print. You can replace the O with the Y, and it'll be YY, and then the rest of my name. You can replace it with a number, it'll replace it with a number. You can also replace the first letter, as you can see here. And last but definitely not least, we have the last method I want to show you, which is name times 3. So basically, you just use the asterisk symbol, sorry, and a number, and you know how many times you want to print the name. So 3 times means 3 times. Um, 10 will print it 10 times, whatever you want. So yeah, that's all for string methods in Python. If you enjoyed, please like and subscribe for more content, and let me know in the comments if you're enjoying these or what I should do different, or what I should add to these types of videos, or what kind of videos you want me to make in the future, or anything at all. Thank you very much for watching, and have a great day. Hello everyone, and welcome back to yet another video. This is the long-awaited video that I've promised you guys, which is all about typecasting. So typecasting is basically the ability to convert a value from one data type to another. So basically, x right here is an integer. As you guys can tell, it's just a number without quotation marks, and it does not have a floating point, so it's an integer. Y is a float since it has a decimal. And then you have z, which is it doesn't really matter the decimal because it's in quotes. So since it's in quotes, that means it's a string. So if I remove this, it's still a string. Okay. So all right, moving on. So basically, I've already declared 3 variables: x, y, and z, integer, float, and string. So typecasting, like we said, is the ability to convert a value from one data type to another. So basically, you can convert this integer into another type of data type. So it could be, you could move it from you could change it from an integer into a string or a float or whatever you want. So basically, obviously not a boolean, because a boolean is only true or false. So in this case, we're going to convert it to a float. So to convert it to a float, basically, all you need to do is, it's pretty simple. X equals to float, and then you just pass in x again, and there we go, it's a float. So if I turn this into a comment right here, if I say print x, it'll just print 1. But if I take this off, move this here, print x, it'll be 1.0. As you can see, it's a float now because we changed it from one data type to another. You could also change it from, instead of an integer or a float, to a string, like we said. But string, you don't type in string, you just type str, and then there you go. It just says 1, but it's not gonna print the quotation mark, so you can't really tell it's a string right now. But there's a way to do it, which is type, and then you pass in x. No, that's not it. Hold on. Sorry. Print and then type, and basically it'll tell you that it's a string. It's in the string class. Okay, so you could do that for other things as well, like print type, and then you can put in, say, y, and it'll tell you that it's a float. As you can see here, let me turn these into a string, into comments. You run it again, it tells you that it is a float. Y is a float. That's how you can basically check what type of data type whatever your variable is. What else? Okay, moving on. You can also do another thing, which is, say, print. Let me show you something. Print z. As you guys know, z is 3.0. It's a string. But here's where it gets tricky. If you do z times 3, you get 3.0 3 times. But that's not what we want. We don't want it 3 times, we want to multiply by 3. So to multiply by 3, again, you use typecasting. You could either turn it into a float or you could turn it to an integer, because with these two things they're both numeric data types, so it will accept a mathematical equation or expression, you could say. So, but it doesn't do that with a string. With a string, it'll just repeat itself 3 times. So again, this is where also typecasting comes in handy. So you type, we could turn it, let's say, float, and then run it again, you get 9.0. If you make it an integer, you run it again, okay, so since it's 3.0, sorry, you can't do that. But if it's 3 and you run it, then you get 9. But since it's because it was 3.0, and 3.0 doesn't accept it, because integers don't have a decimal point, so that's why it didn't work. So yeah, that's all about typecasting. I hope you guys enjoyed this very short and quick lesson. If you enjoyed, please like and subscribe, and tune in next time where we will cover more Python. Hello everyone, and welcome back to yet another video about Python. In this video we're going to be covering user input in Python. So basically user input is kind of like if you've done other programming languages, say for example Java, it's basically like the scanner. So it accepts input from the user. So let's say maybe you ask a question, the computer asks you a question, and then over here you would type in the answer, and then you could send it to the computer, and the computer will store it in a variable, or you can do many other things with it, but that's just one example. So in this case, I'm gonna run a little example with you guys so to help you understand. So basically, we have a variable name. So to accept user input, you could do, this is one of the many ways, but for example, you can do you can put in a variable, and then you can type in input, and input and whatever is in it will be stored into the name variable. So input, and then say what is your name, and then this will ask you a question, what is your name, when you run the code, and then you can put in your name, and then it'll be stored in name. Let me prove that to you guys real quick. Print name. So first of all, it's gonna ask you what is your name. You're gonna type your name. It's gonna be stored in name, and then it'll print the name. So, or no, actually, let's do something better than this. Let's do a couple more. Age, and then say input. How old are you? And then, just for the sake of it, let's also add height. Input. How tall are you? So, first it's going to ask you this, then you're going to type in the answer, then it's going to ask you this, then you're going to type in the answer, then this. And for this one, you need to be careful, because this will be stored as a string. Here, age, we don't want age to be stored as a string, because it's a number, so it's better to just put it as int, and then put the rest in parentheses, and this is basically typecasting, where it'll turn all of this from a string into the integer. And same thing here, height is usually a double value or a floating point value because it has decimals, so you do the same thing, float, and then you put it in parentheses. And then for this, let's make it a little more convenient, I guess. So print, we don't just want to print the name because that's just weird, so we put hello and then name. Next we'll do print, say you are centimeters tall, and then here we will put age, or sorry, height. Oh, I forgot about the age. Let me just move that down then. Okay, so basically, again, there's a problem here, which I talked about before. Typecasting, height is a float, and this is a string. So to put a float or an integer inside of a string, you have to use typecasting. So again, str, and then put the height in parentheses, and there you go. The error is gone. Here, again, print you are age years old. And then again, this is an integer and this is a string. So you have to put it in, you have to typecast. So str, and there you go. That's the perfect code, I hope. So what is your name? My name is Yusuf. Enter. How old are you? 20 years old. Enter. How tall are you? I'm 181 centimeters tall. So, hello Yusuf. You are 20 years old. You are 181 centimeters tall. So, there you go. That's the short lesson on user input. I hope you guys learned something new today. And if you enjoyed, please like and subscribe for more Python and computer science content. Hello everyone and welcome back to another video. In this video, we will be going on about if statements. Basically, an if statement is a statement that helps with making decisions by using conditions. So if a condition is true, it'll execute that block of code. If it is false, it will move on to the next block of code or terminate the program if it's the end of the program. So, for example, before we get into the examples, I want to tell you that there are three parts to an if statement. First, there is if. You can use it by itself, or you could also use if with else, or you could use if with else, but also with else if in between them. So, starting with if. Let's say if your age is equals to 18, print you have just become an adult. So, basically, there's something I want to point out. First of all, wait, let me declare this variable. Age is equal to input please enter your age. Let's make this an integer so we can use mathematical operations on it. So your age, the program will ask you how old you are, so please enter your age. Let's say 18. You have just become an adult. So something I want to point out, like I said, this is the syntax and you need to make sure you get it right every time or else you'll get an error. So you put if and then your condition. So if in our case the condition is if age is equal to 18. Notice how I have two equal signs. One equal sign, like this right here, is for declaring. Two is for comparing. Keep that in mind. And then this is the other side of your condition. And then after that you put the colon. You need to put the colon, and then after the colon, that's where you skip to the next line. And notice how it indents on its own. You need to indent. If there is no indentation, the code, you'll get an error basically, and this will be useless. So you need to indent to let uh, the code know basically that it's going to be, this is what you want to execute if this is true. So moving on. Else age, or sorry, with else you don't put any conditions. Sorry, so it's going to be either if you're 18, it'll print this. If you're anything other than 18, it'll execute this block of code, which is, let's say, you are too young / old. So let's run the code. Please enter your age. Let's say I'm 10. You're too young or old. If you put 100, you're too young or old. So this is where the else if statement comes in. Else if age is, let's say, less or greater than 18, print you're too old. If, or you can use as many else if statements as you want. So else if, gotta pay attention to the indentation. If age is less than 18, print you are too young. So else if, or else, and then you just put, for else you just put, please enter a valid answer. So let's say they didn't put anything above or under or equal to 18, then this block of code will execute. So let's run it. Please enter your age. I'm 10. You're too young. Please enter your age. I'm 20. You're too old. Let's say words, letters. This is an error because I'm trying to store a string inside of an integer, so that's why I'm getting an error. And you can use exception handling, which I'll get into in another video, to basically just keep the code going, keep the program going without getting an error, but that's for a later video. But like I said, I'm 10, you're too old, or you're too young. I'm 20, you're too old. I'm 18, you have just become an adult. And there you go. That's the first exercise and explanation about this topic. Moving on to the next one, I want to talk about booleans. So with booleans, you don't need to do the comparison on your own, it does it for you. So let's say, for example, fast car equals true. If fast car, print this car is fast. Yay. Else means basically if it's not true, then it has to be false. So else print this car is too slow. So this car is fast, yay, because it's true. If you set it to false, the other code will run. So that's about booleans in if statements. So there are two other exercises I want to run by you guys, which is one is answer. So for this, let me explain the code first. So for this, what I'm trying to do is ask a question. If the answer is yes, it'll do this. If it's no, it'll do that. Basically, we have answer equals to input, and what do we want to ask? Do we want to ask I like going to the gym, so do you like going to the gym? And then we can put in some options for the user to see. So he can answer either yes or no. So if his answer is equal to y, which means yes, print let's go. Else let's be sad. So, do you like going to the gym? Yes, let's go. Do you like going to the gym? If you could put N, which will give you a sad face, or you can put anything else since it's else and it'll still give you a sad face. So you can fix this problem again by putting something like elif. Let me just copy this right here.
else. So let's say you didn't say yes or no. Please enter a valid answer next time. And this won't give us an error like the other one because it's a string and we're inputting a string, so it's fine. So do you like going to the gym? Yes, let's go. Do you like going to the gym? No, sad face. Do you like going to the gym? Anything else? Please enter a valid answer next time. So for the third, is it going to be the third? No, for the fourth and final exercise, so this could be a way of exception handling. Let's say a program asks you to input your name. Please enter your name. So basically it'll ask you, please enter your name. After you enter it, it's going to be stored in this variable which is named name. So please enter your name. If name equal, and then if you put empty quotes, that basically means that there's no that basically means it's an empty string. So if the name is an empty string, print you did not even enter a name. Bruh. Else you can put something like hello name. Let's run it. Please enter your name. My name is Yusuf. Hello Yusuf. So if when I input Yusuf, it'll be stored in name. If name is empty, it's going to print this, but it's not empty because I put in my name, so it's going to skip this and move on to the else statement, or the next block of code. The next block of code is the else statement, so it's going to execute this. So hello and then plus name. Or you could just do you could also do it like this, hello plus name. Same thing would happen. Let me just show you. Hello Yusuf. Okay, but keep in mind you have to add a space over here, or else it's just going to be the same word. Sorry. So that's why you gotta add a space here, or you could do it without a space and just add a comma, which is what I like to do. Makes my life easier. So let's try it again with empty. Please enter your name. No, you did not even enter a name, bruh. So there you have it. That's gonna be all for if statements. If you want, I will be having the code in the comments down below. I hope you learned something new today. Please like and subscribe, and have a great day. Hello everyone, and welcome back to another Python programming video. In this video we're going to cover logical operators in Python. So the logical operators are AND, NOT, OR, and they're used to check two or more conditional statements in Python. In this example we're going to use the temperature. So temp, let's put some user input. So please enter the temperature outside. So in Celsius, 0 is the freezing point of water, so it's going to be really cold if it's less than 0, and if it's over 30, that's going to be a bit too hot. So here we have an if statement, a simple if statement. It's going to check this condition and this condition, and the or basically means if this is true or this is true, this is gonna this is what's gonna execute. So let's run it. Please enter the temperature outside, 20. It's not gonna execute anything because it's in the middle of 0 and 30. But if you put, say, 31, the weather is terrible today. Okay, great. Let's follow that up with another if statement. So elif temp is greater than or equal to 0 and temp is less than or equal to 30, then we're going to print some text. So if the temperature is greater than 0 and the temperature is less than 30, so it has to be greater than 0 but also less than 30, because if it's only greater than 0, then it could be 100 degrees outside and this would still execute, but we don't want that. We want it to be in the middle of in this little range between 0 and 30, or else it's going to print that the weather is nice today even if the temperature outside is 100 degrees, which is boiling, the boiling point of water, which is too hot. So the weather is nice today. Let's check. So if we put 20, the weather is nice today. If we put something over 30, or 30 I guess, the weather is nice today. If we put 0, the weather is nice today. But if we put anything other than in between 0 and 30, like -1, it's terrible. Terrible. Great. So we use the or, we use the and. When do we use the not? Not is to completely negate the whole statement. So if not, then if the weather is not less than 0 or greater than 30, it's gonna execute this one. So we're gonna have to make some changes here. So since we added the not to this one, we also have to add it to this one, just to switch things up. 50, the weather is nice today, which is the exact opposite of what we want. You put 20, it's terrible today. Again, the exact opposite. Like I said, the not negates the whole entire thing. So if you want to use the not, we're gonna have to make some changes. So the weather is nice today. The weather is terrible today. Let's check. 20, the weather is nice, still works. 35, the weather is terrible, still works. So this is basically just the complete opposite of what we did earlier, but it's the same thing at the same time. So let's read this just for clarification. If the temperature is not greater than 0, or if it's not greater than 30, it's going to be nice today outside. But same thing goes here. If the temperature is not greater than or equal to 0 and it's not less than or equal to 30, it will be terrible. Let's try it out some more. 15 is nice. 30, nice outside today. 31, terrible. 0 is nice. Less than 0 is terrible. So, I hope you guys learned something new today. Please like, subscribe, and let me know what you want to see more of in terms of computer science videos, whether it's programming or anything else computer science related, and have a great day.
Hello everyone, and welcome back to another Python programming video. In this video we're going to be going over while loops. So basically what a while loop is, it's a statement that will continue to execute its block of code as long as the condition is true. So it's basically one type of the couple conditional statements in Python. So I'm going to be teaching you guys this through a couple of examples, and the first one is going to be a little simple. Basically you have a name variable, and for as long as the name variable is empty, we're going to execute a certain block of code. So basically, while length of name is equal to 0, we're going to be executing name equals input, please enter your name. And then after this is done, we're going to be printing something that says hello to you. So print hello plus name. So let's try it out. So first, oh, oops, sorry. Please enter your name. Nothing. Enter, enter. It's gonna keep asking you over and over and over until you enter your name. My name is Yusuf, so you enter it, and then it says hello, Yusuf. If you run it again, enter, enter, doesn't say anything, put it something, it's hello to whatever you put. So that's one example. There's actually another way you can do this. Another way you can do this same exact program, and I'm going to be showing you. It's name equals to none. You can use the none keyword in Python, which stands for, you know, nothing, or null in some languages, and then while not name, it's going to be name equals input, please enter your name. And then again, it's gonna print this. So let's try it out. Please enter your name. Nothing, 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 nothing. Then when you enter your name, hello Yusuf. This is just a keyword that stands for null, basically. It just means null, which means like same thing here. If it's empty, it has nothing in it, so it's the same thing. And then while not name, while there is no name, it's going to keep executing this block of code. And then when you finally do that, you get out of the indentation. Notice the indentation. Everything that's indented after the while word, after the while statement, it's going to be part of the while loop. And then anything that's not indented with it is going to be outside of it. So after you exit out of this loop, it's going to move on to the next block of code, which is this, and it's going to print this. So I actually have some more examples. Let me just turn this into a comment. And here's one example. So with the while loop, we can execute a set of statements as long as a condition is true. So I equals to 1. While I is less than 6, we want to print I. And then after we print I, we want to increment by 1. So basically, let me just run it for you. 1, 2, 3, 4, 5, 6. So notice it's less than 6, so that's why it stops at 5 and not, it doesn't go up to 6. It doesn't print 6 because it's less than 6. We could also do this, and it'll print up to 6. But if you don't want that, then you just keep it this way. And then let's move on to the next one. So there is a break keyword. The break statement, we can use with the break statement, we can stop the loop even if the while condition is true. So here we have I equals to 1. Let me just so it doesn't get confusing. So I is equal to 1. While I is less than 6, we want to print I. If I is equal to 3, we want to break, and then we want to add by 1. So let's try out this code. So I is equal to 1. While I is less than 6, print I. So 1, it's less than 6, so we go to the next one, which is printing, after we print I, we move on to this. If I is equal to 3, we break. It's not equal to 3 yet, so we move on to this. I plus incrementing by, here we're incrementing I by 1, so I becomes 2. While I equal to 6, print I, which is here, it's 2. If I is equal to 3, we want to break and stop the loop. It's 2, so it's not equal to 3 yet. Okay, moving on. You increment by 1, so it becomes 3. While I is less than 6, so while 3 is less than 6, which is true, we want to print 3. Okay, great. We printed 3, and now we move on to the next one. If I is equal to 3, we break. I is equal to 3, so we break and we stop here. We don't increment anymore, and we're done with this code. If you put it as, say, 4, it's going to print up to 4. If you make it 2, it's going to print up to 2, and so on. With the continue statement, we can stop the current iteration and continue with the next. So, I is equal to 0. While I is less than 6, we want to increment by 1. If I is equal to 3, we want to continue. So, just basically meaning skip. And then we want to print I. So, if I run this code, you can see that 3 is missing because I is equal to 0. While I is less than 6, so while 0 is less than 6, we want to increment by 1. So I becomes 1. If I equals 3, we continue. It's not equal to 3, so we print. Great. We printed 1. And then we go again. I is 1. So while I is less than 6, we want to increment by 1. So I becomes 2. So if 2 is equal to 3, skip. Continue basically means skip, like I said. So it's not, so we print 2. And then it becomes it becomes 3 because we add 1. So if 3 is equal to 3, continue. So I is equal to 3 is equal to 3, so we continue and we don't print 3. And then it goes on until the end of the code. So if we change this to, say, 5, it'll skip 5. So moving on to the next block of code and the last one. So with the else statement, we can run a block of code once the condition no longer is true. Once the condition is no longer true, sorry. My bad. So I is equal to 1. While I is less than 6, so while 1 is less than 6, we want to print 1. And then we increment by 1, so that becomes 2. Else, we print this. So if this is no longer true, we print this. I is no longer less than 6. Run it. 1, 2, 3, 4, 5. And then when it becomes 6, we say it's no longer less than 6 because it's equal to 6. So if you change this to, say, 10, and then you're going to have to change this to 10 as well. I is no longer less than 10 because it goes, okay, let me spell it out for you. I is equal to 1. While 1 is less than 10, we want to print I, which is currently 1. And then after you print it, right here, we want to increment it by 1. So we increment it by 1 and it becomes 2. So we go back. It's still true because 2 is less than 10. So you print 2 and then you add 1. So it becomes 3. 3 is less than 10. So you print 3 and then add 1. So it becomes 4. All the way up to 10. So when it becomes 10, I is no longer less than 10. So we stop there. I hope you guys learned something new. And please like and subscribe for more Python content and computer science content. And have a great day. Hello everyone, and welcome back to another Python video. In this video, I'm going to be talking about for loops in Python. So unfortunately, I already talked and recorded this video, but there was some problem with the audio, so I'm redoing it now. So that's why the code is already ready. But without further ado, let's get started. So a for loop. A for loop is a statement that will execute its block of code for a limited amount of times, and that's basically the only difference between a while loop and a for loop. A while loop is unlimited, whereas a for loop is limited. So here we have the first example. For I in range 10, we want to print I plus 1. So the range is, as you can see, it's kind of like the limit, right? So for I, it doesn't have to be I, it could be like any letter or name or whatever, but I is just the preferred letter that most people use. So for I in range 10, print I plus 1. So as you can see, it starts off as at 1 all the way up till 10. 10 is the range, so once it hits 10, it's gonna stop. And then I starts off at 0 and it adds 1. So 0 plus 1 is 1, so it prints 1. And then it becomes 1. So 1 plus 1 is 2, so it prints 2, and so on and so forth. So let me turn this into a comment and let's move on to the next example. For I in range 50, comma 100 plus 1, comma 2, print I. So can you guess what this code does? Pause the video and guess, maybe think about it a little bit. Basically, this code means it's going to start off at 50 and it's going to end at 100 plus 1, and then it's going to increment by 2. And then it's going to print I. I is whatever the range, whatever it is in the range. So it's going to start off at 50. That's the beginning of the range, and the end of the range is 100 plus 1, so 101. If you change it to 100 only, it won't print the 100, so you have to put 101 or 100 plus 1. And then 2 is how much it's going to increment by. So if you change it to, say, 4, it's going to increment by 4. 50, 54, 58, 62. And if you change it to 1, same thing, it's going to increment by 1s, as you can see. But we want it to increment by 2s, so that's it right there. So for the next example, let me turn this into a comment and uncomment this. For I in Yusuf, which is my name, by the way, we're going to print I. So can you guess what this does? If you guessed it's going to print from 1 to 6 because it's 6 letters, you're wrong. It's a string, so it's going to print each character in the string. Y-O-U-S-E-F. So it's going to print Y. It's going to go through like the string, so Y, and then it's going to print it. And then it's going to go again. O, print. U, print. S, print, and so on and so forth. So for the last, and definitely not least, example, this is the most complicated one, but it's very easy, so don't be scared. Just bear with me. First of all, you're going to need the import, which is time. So after you import that, we start with 4. And here, again, this is just the name. You can change it to I if you want. It works the same, but I just like to keep it as seconds just to make it easier on my brain, right? So for I in range 10, comma 0, comma minus 1. So it's the same logic as right here. Gonna start off at 10. The beginning, the first number is what it starts with. So 10, from 10 to 0, and we're gonna decrement by 1. And then it's gonna print seconds, and then time.sleep. Sleep is basically just a method of this library, time. It's just a method that pauses the program. It basically delays, as you can see, delay execution for a given number of seconds. So 1 means 1 second. 10 means 10 seconds. 100 seconds. 1,000 seconds. But we want it to sleep for 1 second. And as you can, if you pay attention to the indentation, this is indented and this is indented. And that means it's part of this for loop. This right here is not indented, so it's only going to execute after the for loop is finished, not before and not during. So once this gets to 0, this is when this will execute. So let's run it. And as you can see, it starts off at 10, 9, 8, 7, and it keeps going. And then when it goes to 0, that's when it ends, and then it tells you to like and subscribe. So please do that. If you enjoyed this video or learned something new, like and subscribe, and stay tuned for more Python and computer science videos.
Hello everyone, in this video I'm going to be talking about collections in Python. So, collections are basically variables used to store multiple values. There are 4 types of collections in Python. We have dictionary, lists, tuples, and sets. So I already went through the trouble of writing down the code for the dictionary, and we will write the code for sets, tuples, and lists together. So as for the dictionary collection is changeable and it's unordered, and it uses key value pairs, and it's very fast because of hashing. Hashing is basically where you use the key to find the value of whatever, to find the value that's stored in the key. So, without further ado, let's get started. So to declare it and start out, we just use animals or a name for the variable, which is the collection, which is the dictionary. So you use a name for it. In this case, I named it animals, and then equals, and then curly braces, and inside you could have a key and a value. So for the sea animal, we have a whale. For the land animal, we have a tiger. For the amphibian, we have a crocodile, and for the bird, we have an eagle. So, as for the normal way of accessing a value in a dictionary, you can use the key. So, in this case, we have print animals and then you pass in bird. Bird is the key for eagle. Eagle is the value. So, print animals and then you pass in bird. You run this code and you get an eagle. If you change it to land, so you can see what the land animal is, you get tiger. Moving on. So it's safer to use the get method to access a value so you don't get an error if it doesn't exist. Let me show you what I mean by that. So here we're trying to print animals.getBug. So we're trying to print the key is bug. We're trying to print it, and as you can see here, none of these keys are named bug, so it doesn't exist. But if you run the code, it'll just give you none. But if you write bug here, you will get an error. You will get an error because it does not exist. Moving on. Let me just fix this. Moving on. So, to print the keys only, this is a method we could use to print the keys only. So, print animals.keys. .keys is the method, so you print it and dictionary keys, sea, land, amphibian, and birds. This is to print the keys only. So to print the keys and the values, you use print animals.items, which items is basically the key and the value, like I said. So I don't know why that didn't work the first time, but there you go. I think I didn't have parentheses maybe, I'm not sure, but yeah, there you go. So as you can see, it prints out C, which is the key and the value, key and the value, key and its value, key and its value. So another way of to display the key value pairs, which is this is a longer, more complicated way, so I don't recommend this if you're a beginner, but you use a for loop. So for the key and value in animals dot items, so for all the items in animals, sorry, for all the keys and values in animals dot items, which means the keys and values, we want to print the key and the value. So as you can see, this does the same thing without the extra stuff. It just prints it out like that. So one way to change an item is to use the update method. So if you want, you can update it this way. If you run the code here. Oh, okay, sorry. I'm supposed to use a colon. I messed that up. So to update, we put animals.update and then you put parentheses, and in the parentheses you put the curly braces. In the curly braces you put the key and the value. And to prove that to you, let me just print animals, and there you go. At the end you have the bug, which is the housefly. So to remove an element, you could do two things. First of all, you could pop it by its name. So pop bug, and you can't see that right now because it's not printing the new version. But if you print the new version, then as you can see, you don't have the bug. Or you could do another way, which is pop item. Pop item basically pops or removes the last inserted key value pairs. So try it again. Sorry, let me print it out. And again, it's gone. Or sorry, now the bug is gone, and whatever the last one is, which is the bird. Okay, so to remove all items, of course, you just use clear, run it, and it's empty, as you can tell. So, moving on. Next is going to be lists. So, as for lists, they are ordered and changeable, or you could say mutable, which also means the same thing, changeable basically. And in lists, lists allow duplicates, and to start a list or to declare the list, you basically use the square brackets. So it's the same thing. You just put animals as, you know, whatever you want your name to be. For me, I'm going to use animals, and then tigers. Let me just add. So for the lists, we have a couple methods, and you can actually see the attributes and methods of a list by typing print dir, which is stands for directory, and then animals. Let me just turn all this into a comment so that doesn't interfere with what we're going to do next. So to print this, it's going to give you a list of all the attributes, which we'll probably get into in another video, and at the very end you can get to the methods for the list. So moving on. If you don't know what any of these mean, you could also do something else. Print help animals, and then you run it, and then here you could get a list of everything, of all the attributes and the attributes and the methods for the animals list, methods and attributes and methods you can do to this list. So like copy returns a shell copy of the list, count, basically you could read through all of it and just learn more about it. Next, print len of animals. Basically, I'm sure you can guess what this does. It prints the length of animals. So we have 4 animals, so the length is 4. Okay, so next is going to be checking if a key or an element is stored in this list. So print, say, tiger in animals. So if this is true, it'll be true. If we say bug, it'll be false. Moving on. Print animals so it'll print the first element in the list animals. So in this case it'll print tiger. Moving on. Moving on. So you could actually replace an item as well by typing the name, and then if you want to replace this one you put 0, this one is 1, 2, 3. So let's replace the horse, so 2, because you know computers start at 0, so 0, 1, 2. So if we want to replace the horse, we do that, and then we say we're going to replace it with a turtle. Damn, I can't spell. So there you go. Let me just print animals. as you can see, the horse has been replaced with a turtle. Next, we can append. Append is basically just adding to the end. So append turtle. As you can see, at the end there's a turtle. You can also remove an item. So animals dot. You can also see all the attributes and methods from here if you forget something. They usually just pop up when you write the beginning of it. So here, remove, as you can see, it just shows it for you. You could just press enter and remove, and then say tiger, and then you run it. Tiger is no longer there. Okay, and then we could also insert animals dot insert, and then you can insert it at whichever index you want. So in this case, we are going to be inserting at 1, comma, let's say turtle. So at index 1, we're going to be replacing it with turtle. So there you go. Or sorry. You're not going to be replacing, you're going to be inserting. Sorry, my bad. So at 1, we're going to be inserting turtle. So it's going to be 0, and then 1 is going to be turtle, and then it's going to go on with the rest. Okay, cool. Next is going to be sort. Animals dot sort. So when you do this, it's going to sort them out in alphabetical order. So H is first, and then L, and T, and then W. You could also do something. See, if you do this, you could also reverse, right? And if this is commented out, then there's no use of reversing it because they are unordered. So it's always going to be weird, right? It's just going to be reversed in the order that you inserted all the values in. But if you want it to be reversed in alphabetical order, then you have to sort it first and then you reverse it, and there you go. It starts with W, T, L, H. Moving on. You can also clear, again, of course, animals dot clear, and then you print the animals and it's empty. You could also find the index of the animal you're looking for. So print animals dot index, and then say you're looking for a tiger. It's at 0, and as you can see here, it's at 0 because it's the first one. And then you can also print how many times an element is in that list. So because as you remember, it allows duplicates. So animals dot count, and then tiger. So here's gonna return 1, but if we say, oh no, if we have 2, it's going to return 2, but we only want 1 for now. So moving on. I think that's it for the lists. Now we're going to be going into sets. So as for sets, basically for sets you use curly braces, and they are unordered. So the list was ordered. Sets are unordered and immutable, which means they are unchangeable, but you can add or remove elements. Also, it allows no duplicates. Okay, so let's do this again, except in this case I'm just gonna do this, then this, do this. So this is now a set. So for sets, we have a couple methods as well. You could do the same thing in terms of this, in terms of all of these methods, you could do the same thing, which is pretty self-explanatory. I'm not going to go through them again. But basically, some more methods. And just as a reminder, you could print. Okay, so notice how I got an error here. Why did I get an error? I got an error because they are unordered. So each time the object is gonna be subscriptable. Basically, it's never gonna be the same object. Like as you can tell, let me show you. Print animals. Okay, tiger, horse, wolf, lion. Print animals again. Lion, tiger, horse, wolf. Print again. It's different order. Print again. They're always different orders. It's just random orders. So if you try to print some kind of index, it's going to give you an error because they're not always at the same index, so that's just weird. You could also, like we said, you could add, say add a cow, print animals, and you have a cow. I don't know why this says none. I'm not sure what. Oh, I don't need to have a print statement there. Okay, so at the end you have a cow. You could also remove. I don't know why I'm typing print first. It's just a habit at this point. Remove cow. You run it again, cow is gone. Yeah, we added a cow and then removed it and then we displayed animals. Okay, moving on. You could also pop dot pop, and as you can tell, we removed the tiger in this case. So each time it'll just remove something random. So in this case it's a tiger, in this case it's the wolf, and in this case it's the tiger again. And again, it's always in different order. So we can also clear animals.clear, and it's just an empty set. So moving on, we are now going to be talking about tuples or tuples or whatever you want to call it. So for tuples, we can declare it by using parentheses, and they are ordered and immutable, so you cannot change them. Duplicates are okay, and these are faster than lists. So if you care about speed in the future, maybe if you're writing a big program, it's better to use tuples. If you don't care about how that it's immutable, because here this is ordered and mutable, this is ordered and immutable. So if you don't care about changing anything later, it's more efficient to use tuples instead of lists. So to use it, like I said, we use parentheses. So here I'll use parentheses, and there you go, you have a tuple. So for a tuple, you have the same thing. You can you can use these as well here. So for this, we're going to be print some methods. I'm going to be showing you guys some methods basically. So for here, we can print animals, and then at the index, so for the animal, say lion, we want to check the index of lion. Where is lion at? Lion is at 3, so 0, 1, 2, 3. Great. So we also want to count how many times lion is there. So print animals dot count and then lion. We only have lion one time, so it's just gonna return 1. Okay, great. So next, you could also print animals this way, or you can print it another way, which is for animal in animals print animal. So this is to get it in this way, and this is this is to get it this way. So you can also, like, usually in for loops you would see for x in animals print x, which is the same thing. It does not matter at all as long as this is the variable name that you want to print from. But in this case, I want to use animal so that it's easier to understand. The way I think of it is like for each animal in animals, we want to print the animal, and then it just iterates through it and it's there. So I hope you guys enjoyed, and I hope you guys learned something new today. If you did, please like and subscribe and comment on what you would like to see some more of, and have a great day.
Hello everyone, and welcome back to another Python video. In this video we're going to be going over nested loops in Python. So a nested loop is basically two loops within each other, or one loop within another loop. So the inner loop will finish all of its inner iterations before finishing one iteration of the outer loop. So let me demonstrate this with an example. So we can start with declaring the variables. So let's say we have rows, columns, and symbols. So rows, and then we have to typecast into an integer, and then to accept user input we put input, and then we ask how many rows would you like, and then same thing here for the columns. And then last but not least, the symbol you'd like to use. You can choose any character. And for this you don't need to typecast because it's already a string, so it doesn't matter. We don't need it's not a number, you know. Enter a symbol. So this is where the nested loops come in. So we start with a for loop, for I in range, and then say we want to start with the rows. So for I in the range of the rows, which is whatever you select with the user input, and then to make it a nested loop you have to put another loop within it. So for j in range, and j will be in charge of the columns. So we want to print the symbol, and to get everything on the same line you have to put end and then an empty string. If you run it, this is what you would get, but we don't want that, right? We want to have like a square, I guess you could say, of threes. So to fix that problem, you add a print line statement at the end, and then you run it again. 3 rows, 3 columns, with the symbol 3, and as you can see, it's a square. And then you can do it again with whatever you want. Say 5 rows, 2 columns, and a $sign. Enter, and there you have it. So that's nested loops in Python. This is just a quick and easy, simple example. So you can also do this without the user input, and basically I just took the same code here and I replaced rows and columns with 3 and 3, and I and j are the same, and then replace symbol with j. So it's basically the same thing, it's just a range, so from 0 to 3. So it starts off at 0, 1, 2, and then, oh sorry, it's here, 0, 1, 2, and then it prints 0, 1, 2, prints again, 0, 1, 2, and prints again 3 times. And then if you change this to 5, you'll have it 5 times. And if you change this to 5, you'll have it go up to 5 numbers. So from 0, 1, 2, 3, 4, 5. Or sorry, 0, 1, 2, 3, 4. And that's 5 numbers from 0 to 4. You can also do it as 1, 5. 1, 5. And that's just from 1 to 4. So it's basically just think of it as 5 minus 1, and that's how you get it, you know. So if you change this to 6, it'll stop at 6. I mean, stop at 5, sorry. And there you have it, nested loops in Python. If you enjoyed this video, please like and subscribe, and stay tuned for more computer science and Python videos. Hello everyone, and welcome back to another Python video. In this video, we're going to be talking about indexing in Python. So the index operator is these 2 brackets, and it basically just gives access to a sequence's element. So if it's a string or a list or a tuple, you can use indexing because they allow indexing. So to start off, we have a variable, which is my first and last name, with an exclamation mark. So you can use indexing to capitalize the first letter. So we can do that with a simple if statement. So if name, and then this is where you use the indexing. So 0 is the first character because computers always start with 0, and then use the is lower method. Name equals name dot capitalize, and let's print name. Sorry, hold on, I have to just current file, run it, and there you go. It was lowercase and now it's capitalized. So that's our first example. In our second example, we're going to be making the first name all uppercase, and here's how you do that. So you can first start by declaring a new variable. So first name equals to name, and then indexing again. So this operator 6 dot upper. So let me explain this a little bit. So first name, this is going to be our new variable, and it equals to the variable we already have, and then colon 6. Colon 6 basically just means everything before the 6. So you have 1, 0, 1, 2, 3, 4, 5, 6. So everything before right here, as you can see, 6, and before it is empty. Here you could also have 0, it would have the same effect, but we're just going to keep it simple and keep it like this. So you come here and print first name, run it, and you get my first name, and it's all uppercase. And for the next example, the third example, we're gonna be making the last name all lowercase. So let's just change this to, some of it can be uppercase just to make the example, just to see if it works or not. So last name, again we start with by making a new variable equals to name, and if we ended at 6 for the first name, that means we gotta start at 7 for the last name. So 7, and then you just reverse it, right? We put the colon on the right, we put the number on the right side of the colon. Now we put it on the left side because we want the end. So here it's 6 is on the right side because we want whatever's on the left. And here we want what's on the right, so we put the 7 on the left, and we put the colon here, meaning everything else that's on the right. And we use the the lower method. And you run it. Hold on, let me print last name, run it, and there you go. It's all lowercase. Before it had 3 uppercase letters, but now it's all lowercase. So last but not least, we have one more example, and it's that we're going to be making a variable of the last character in this string. And -1, which you'll see shortly, means the first character starting from the end. So basically, from the end, moving back. So last character, new variable, equals to name -1. And then we print last character, run it, and as you can see, it just prints the last character. If you put -2, it prints the second to last character. So this is the last character. If you print 2, it'll go, okay, this is 1, 2, so it'll print D, and then 3 would be A, and then 4 is M, 5 is A again, and so on. So that's it for Python today. That's it for the Python video today about indexing. If you enjoyed this video or learned something new, please like and subscribe, and stay tuned for more Python and computer science content. Hello everyone, and welcome back to another Python video. In this video, we're going to be explaining loop control statements, and these are known as break, continue, and pass. So loop control statements are just statements that change a loop's execution. It basically derives it or deviates it from its original sequence or execution. So there are 3, like I said. Break is used to terminate the loop. It just cancels it completely. Continue skips to the next iteration, and pass just does nothing. It acts as a placeholder, because sometimes in some Python statements you just can't leave it empty, so you enter or you type pass, so that acts as a placeholder to do nothing basically. So we have a few examples, and the first example is going to be a code that doesn't stop running until you enter your name. So we can do that with a while loop. Wait, so I have caps lock on. So while true, we want to declare a variable first and accept user input, so input, and enter your name, please. And if name does not equal a string, we want to break. Enter your name, please, Yusuf, enter, and that's it. The program terminates. But if you don't enter a name, press enter, asks you again, enter, enter. It's going to keep asking until you type something, and then that's when the program stops. So that's the first code, first example. And then we have, and that's for the break statement. So we have another code, and this is going to be a code that doesn't print the dashes in your phone number, just the phone number itself. So first let's declare a phone number. Wait, sorry, my bad. Rookie mistake. Phone number equals, and let's say 1 2 3 1 2 3 1 2 3 4. That's our phone number. And then we want to, for I in phone number, we want to say if I equals to a dash, we want to continue. So just skip over it, don't print it. And then of course we're gonna have to print I, and we want to end it with, so that this is basically just to ensure that all the code prints on the same line, because without this it's just gonna print 1 2 3 1 2 3 1 2 3 like vertically, you know, instead of like this on one line. So here you go. I should probably turn this into a comment and run it again. So as you can see, it prints the whole thing without the dashes. If I remove this, it's just gonna print it vertically like I said, so we don't want that, so we keep this, and it prints it on the same line. 4 5 6 7 8 9 0. Run it again, same thing. And then you can change this in any way you want. You can say if I equals to, say, 1, continue. So you run it and it skips 1 and it keeps the dashes. So you can play around with it however you want, but this is just a small simple example. So let's turn this into a comment. And last but not least, we have a code that prints all the numbers in a range but skips a specific number. So for that, we're going to use a for loop again. So for I in range, say 1 to 10, we want to say if I equal, so which means if I equals to, and then you can just choose whatever number. In this case, let's use maybe 5. We want to pass. If it equals to 5, if I equals to 5, we pass. Else, print I. So if I equals to 5, we pass. We don't do anything. You know, it's just a placeholder, so it does nothing. Else, so if it's not equal to 5, we want to print whatever that is. So as you can see, 1 2 3 4 skips 5, 6 7 8 9. And this is, it stops at 9 because 1 to 10, it just doesn't count 10, right? So if you want to count 10, you just say +1, or you can change it to 11, whatever you want, and it counts 10. And then again, of course, if you want to change the number, you can make it 9, and as you can see, it skips 9. If you want to say 10, skips 10. So yeah, that's it for today's Python lesson. If you enjoyed this video or learned something new, please like and subscribe. And as always, this whole code will be posted in the comments down below. And I'll see you guys next time. Hello everyone, and welcome back to another Python video. In this video, we're going to be going over functions in Python. So a function is a block of code that is executed when it is called. And sometimes, not always, but most of the time, you're going to need two things known as arguments and parameters when you're using functions in Python or any other programming language. So information that is sent to the function after compiling the code, that information is known as arguments. But parameters are information that is waiting for the arguments to be sent to it. So basically it's just a slot, and I'll demonstrate that with an example to help you understand. So in this example, we're going to be making a function that gives a basic greeting. So to start any function in Python, you need to start with the keyword def, which stands for define. So you're defining a function, and the next thing that you type is what you're going to be naming it. So define hello. And then we need to set the parameters. So say fname, lname, and age. These are the parameters. And then you need to give it a few statements, because this is just the name of the function, and this is just the function, and you need to give it a block of code. So the statements, we're going to be using print statements because that's the simplest. Hello. So the reason I'm using commas is because when you use commas, you don't really need to add a space, so it makes it a lot easier. So to call the function, let's just say hello to call the function, and then you need to give it parameters. So for the first parameter, or argument, sorry, for the first parameter, we're going to be sending an argument, Yusuf, and then my last name, and then my age. Well, I'm 21 now, so you run it and it says hello, and hello Yusuf Al-Hamid, so it greets you. So you can add a little more to it. Print you are, and then you need type casting, string, age, years old. You are, age, years old. So when you send the argument, which is 21, it'll tell you that you're 21. So run it again. Hello, you are 21 years old. And we can add some more to it. Something simple like, sorry. So that's basically it. You can also add, you can change the arguments however you want. So hello, and then you can change it to say Will Smith. And I don't know how old he is, so we'll just put 40 because that's, I guess he's old, that old. So hello Will Smith, you are 40 years old. Please like and subscribe. So if you learned something new or enjoyed this video, please like and subscribe, and stay tuned for future Python and computer science videos. Hello everyone, and welcome back to yet another Python video. In this video we're going to be going over return statements in Python. So return statements are functions send Python values or objects back to the caller, and these values slash objects are known as the function's return value. So you'll understand that better with an example. So we have an example here, and it's an example that's going to be returning a product of a multiplication equation. So define multiply, and then you have number 1 and number 2 as the parameters, and then you want to return number 1 times number 2, and we want to say x is equal to, and then you call the function, which is multiply, and you can choose any number, say 5 and 5. So 5 times 5, which equals 25, and we want to print x, and then you run it and you get 25, and you can change that of course to anything, and you run it again, you get 50. So this is a function that multiplies number 1 and number 2 and returns it, and here we have x, which is a variable, and we're storing whatever it returns into this variable, and then we're printing the variable, and that's how you get the answer here. And these are known as arguments, these are known as parameters, because they're within the function, and the arguments are entered information that is entered into the function. It's sent to the function to be placed within the parameters. So 5 is in number 1 and 10 is in number 2. So that's it for this small and short Python video. If you liked this video or learned something new, please like and subscribe, and stay tuned for future Python videos. Hello everyone, and welcome back to yet another Python video. In this video we're going to be talking about random numbers. So first, before you start anything, of course you need the random import at the top, and let me demonstrate how to use random numbers with a few examples. So for the first example, we're going to let the Python program choose a random number between 1 through 6. So kind of like you're rolling a die, right? So x, of course, you have to define a variable, or declare a variable, sorry, and then you use the random function, and then rand int, and you need to set the arguments 1 through 6. And let me just print that here. Print x, you run it, you get 3, run it again, 5, run it again, 1. So as you can see, you're getting random numbers from 1 through 6 every time you run it. So that's the first example. We have another example, and as you may notice, I'm using rand int here, but I won't be using it here, and you'll see why. So the second example, random numbers between 0 to 1. Y equals to random dot random, and you don't put anything in the parentheses, and you run it. Wait, sorry, let me print y, and then you run it, and as you can see, you're getting random decimal like a random floating point number from between 0 and 1. So here we're using rand int, which means integer, which means it has to be a whole number, right? It can't be a floating point number like this. It has to be 1, 2, 3, 4, 5, 6, 7, you know, like that. But here we're just using random, and it's from 0 to 1. It's automatically between 0 to 1. You don't need to put 0 and 1 here. And as you can see, it is a decimal because I didn't put rand int. If I put rand int, it would be a whole number, not a decimal. Moving on, we have another example. Say you want to play rock, paper, scissors with the computer. So first you have to make a list. So my list, rock, paper, and scissors, and z equals to random dot choice, and then we pass in my list as the argument, and then we want to print z. So what I'm doing here is, first of all, I made a list. I declared a list, and then I added 3 elements within the list: rock, paper, and scissors. And then I made a variable. I declared a variable, and I used the random method, and you know, it chooses a random, the choice method within the random method chooses a random element from a non-empty sequence. So as you can see, this is a non-empty sequence, and we're gonna be choosing something from my list, and it's gonna be in z. So we need to print z. I hope that was easy to understand, because I feel like I explained it terribly, but as you can see, you print it once and you get scissors. And let's say we want to choose rock, and let's see what the computer chooses. Rock. I chose rock and the computer chose scissors, so I win. Again, I win. Again, now the computer wins. And it's just random, as you can see. Rock, paper, scissors, over and over and over again. We can also demonstrate this with another example, a bigger example. So we can have like a deck of cards basically, and we enter them in a list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have a jack, a queen, a king, and an ace. Sorry, there we go. So you can shuffle the cards. So random dot shuffle, and then you pass in the cards as an argument, and then you print the cards. So as you can see right here, they're in order: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. And you have the random function, and you want to shuffle them. So you shuffle the cards, you pass in the cards as your argument, and after you shuffle them, you want to print them. So after you print, as you can see, they are very, very random. You print them again, random. It's just shuffling randomly. So that's basically it for this Python video. I hope you enjoyed this video or learned something new, and if you did, please like and subscribe and stay tuned for more computer science and Python content. Hello everyone, and welcome back to another Python video. In this video we're going to be talking about keyword arguments and positional arguments. So keyword arguments are arguments preceded by an identifier when we pass them to a function. The order of the arguments does not matter, unlike positional arguments. So with positional arguments, the order matters. It's in the name, positional. And with keyword arguments, it doesn't matter. The order doesn't matter because we use an identifier. So Python knows the name of the arguments that our function receives. And here we have two examples that will hopefully help you understand keyword and positional arguments a little better. So the first example is about using positional arguments with the help of a function, of course. So we have a function, def, which stands for define, hello, and within the hello function, we will pass in a few parameters, so fname and lname. And just for the sake of it, let's also use mname. And of course we need to add a colon and then indent and print hello. Wait, sorry. Fname, mname, and lname. So these are the parameters, and this is the block of code that will execute when we call this function. And as you can see, I used commas here because if you don't use commas, you're gonna have to use two pluses, and then within the plus you're gonna have to add a space, and that's just too much of a hassle. So when you use a comma, it just automatically adds a space after whatever it is. So after fname, there's gonna be a space, mname, there's gonna be a space. So that's why commas in Python are very helpful. But moving on, then we call the function, and to call it, we're using positional arguments, which is a lot easier to think of it, but when you think of it, but keyword arguments are a lot more organized and there's a lot less room for error. So you call the hello function, and then you have three parameters, so we need to pass in three arguments. So for the first one, for the first name, F name, we add Yusuf, and then say this is my middle name initial, and then this is my last name. So let's run it. And hello, Yusuf A. Alhamid. So it works. And if you change the order around, so say you add this at the end, and you run it, it's going to be different. It's going to be incorrect. So let's keep it that way. Let's keep it the correct way. So this is positional arguments. For the next example, we have an example for keyword arguments. So it's basically the same thing. So I'll just copy paste it just for simplicity and time. So it's the same thing, but let's first of all change the name of the function so we don't get errors. And we have F name, M name, L name, and then we have the hello code that will, the executable code. If after we call this function, this is what's going to execute. But the real difference is over here. This is how you use keyword arguments. So this is F name. If we're using positional arguments, this is how it would be, exactly like this. But since we're using keyword arguments, since this is the F name, we take this, copy, paste it, F name equals to Yusuf. And then for the M name, we do the same thing. M name equals that. L name equals that. And then you run it, and you get the same exact thing because we're using keywords. If you want, you can also use a different order here. It doesn't matter. Like I said, there's a lot less room for error. So as you can see here, M name is first, then F name, then L name, and you run it, and it's still the same thing. Even here, if you change these around and you run it, it's still going to be the same thing. If you want it to be a different order, then you change it from here. So if you change F name to over here and you run it, now it's weird. Now the middle name is in the middle, in the beginning, and the first name is in the middle, as you can see right here, and the last name is, that didn't change, so it's fine. So yeah, that's it for this lesson today. I hope you enjoyed this video or learned something new. Please like and subscribe, and stay tuned for more Python and computer science content. Hello everyone, and welcome back to another Python video. In this video we're going to be going over variable scopes in Python. So the scope is the region that a variable is recognized. A variable is only available from inside the region it is created in. A global and locally scoped versions of a variable can be created. So you can have both a local and a global. It depends on what you want. And a variable is only available from inside the region it is created in. So if you create it globally, it will be available globally. If you create it locally, then it'll only be local. And I'll help you understand with the help of a few examples. So for the first example, we have a global scope available inside and outside all functions. And so you can start with, like, say name, and then my name is Yusuf, so there it is. That's a global variable. And if you type print name and you run the file, you'll get my name. But you can create a local variable, and to do that, say you define a function. So define, say, print name. Let's call the function print name, and then within the print name function, we want to create a variable, call it name, and then for this, let's say hello, or let's say like something like David, make more sense. So and then print name. So this right here is a local variable. This is a global variable because this is within this function. So it's local to this function only. It can't be accessed from outside this function. So let's say if you call it name1, okay, if you say here print name, print name. Okay, print name works as you can see because it's a global, but print name1 doesn't work. You get an error. So this is local scope. Okay, let's run this. So if we run it, again, we're just printing the name. So we need to print this, we need to call the function. So I can't type today, sorry. Print name. You run it, and you get the name. And here, if you say, yeah, that's basically it, sorry. So if you call the print name function, it will print the name. If you just print the name, it will print this name. It will print Yusuf because this is global, whereas this is local. So to access this one, you're gonna have to call the function, and you can make them the same name because this one is local, whereas this one is global. So it doesn't matter if it's the same name because they're basically stored in two different areas. So that's basically it for this video today. If you enjoyed this video or learned something new, please like and subscribe, and stay tuned for more Python and computer science videos. Hello everyone, and welcome back to another Python video. In this video we're going to be going over args, or that also stands for arguments in Python. So args is a parameter that will pack all arguments into a tuple or tuple, useful so that a function can accept a varying amount of arguments. So when you don't use args, you have a specified amount of arguments that you can add to the function or use in the function. But when you do use args, as you can tell, it can accept a varying amount of arguments. So let me give you a few examples to help you understand this better. So first we have a function. Let me give an example with a function. Sorry about that. So in this function we aren't using args, so we can only use two arguments. So this is what a normal function would be without using args. So we define a function and call it add, and then within the add function we have two parameters, number1 and number2. And in this function we want the sum variable to equal to number1 plus number2, and then we want to return the sum. And so to call this, we print add and then say 1 and 2, and then you run it and you get 3. But then if you add 3, you get a problem. As you can see, add takes 2 positional arguments, but 3 were given. So I gave 1 too many arguments. So this is the only way this could work. If you use 2 digits only, like I could use like this much, whatever, it doesn't matter, as long as it's only 2 values, 1 value, 2 values. So this can like be also like another number, whatever. It works only if you use 2 values. But if you use 3, you get an error. So this is without using args. So we have another example over here. This is a function in which we will use args, and we will be able to use as many arguments as we want. So to do that, we need to define another function. So define add, and then we use an asterisk, and then args. Sum equals to 0, and then for I in args, sum plus equals 1. Oh, sorry, plus equals I. And then we want to return the sum. So let me turn this into a comment first, and then I'll explain this. So for the parameter, we have args, which, like I said, it takes a varying amount of arguments. It doesn't matter how many. And then sum equals to 0, because that's how you want it to start out with. And then for I in arguments, we want the sum to increase by I. So for each value in the arguments that we passed in, we want the sum to increase by that amount. So for example, the sum is equal to 0. If we add in a 5 in the arguments, then I will be 5. So the sum will be at, like, 5 will be added to the sum, and then we return the sum. But if there are more, then it'll be 5 plus whatever, plus whatever, plus whatever, plus whatever, up till the end, up till like we have no more values to add, and then it'll return the sum. So I added that I made that as a comment. So let's run this. Wait, I made a fatal mistake and I forgot to call the function. So print add, and then we add 1, 2, 3, 4, 5, 6, and then we add all those together and we get 21. As you can see, 6 plus, let's do that together. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, and then 15 plus 6 is 21. And as you can tell, you can add as many numbers as you want. It will still run, and it will calculate everything perfectly. Okay, so one last thing. Tuples or tuples are ordered and unchangeable. So if you want to change it, you'll have to cast it into a list or a changeable type of collection. And I'll show you with an example, but first let me clarify something. As we said, it packs all arguments into a tuple. Okay, so it's a tuple, and tuples are ordered and unchangeable. So if we want to change it later, we can't. So that's why we have to turn it into a list if we want to change it later. So let's start at 69 because that's nice. So define add as usual, and then we add args. Sorry. Okay, and then sum is equal to 0, of course, and then args equals to list args. That's how you turn it into a list instead of a tuple. And then args of index, wait, sorry, I don't know what I just did. Oops. Yeah, so args of, yeah, there we go. Args of index 0 equals to 0, and then for I in args, we want the sum to increase by I, and then finally we want to return the sum, and we run it. Oh, oops, again, same mistake. We want to print add 1, 2, 3, 4, 5, 6, and as you can see, it says 20. It's different. Why is it different? So it's different because this code, this specific code right here, it accepts all of this except this. So this is equal to 0 because at index 0 it equals to 0, but then everything here gets added. And I'll prove that to you with another example. So if we change this to 1 and we change this to 6, it'll be 15 because 2 plus 3 is 5, and then plus 5, that's 10, and then plus 4 and 5, that's 15. So the 6 is not included. And that's basically it for this video today. If you learned something new or enjoyed this video, please like and subscribe, and stay tuned for more Python and computer science content. Hello everyone, and welcome back to another Python video. In this video we're going to be talking about nested function calls in Python. So a nested function call is pretty simple, and I have two examples here to help you understand. So it's basically just a function call inside another function call. So what you need to know is that the innermost function is what will be executed first, and it'll move out with each after each time the first function, the innermost function finishes, it will move out to the outermost one. So the returned value is what will be used for the next outer function. And I know that sounds really confusing right now, but I'll help you understand with an example. So first, let's use a normal function to help you understand. So we have a number, and let's say it will ask you to enter a positive number, and you run it, and it just asks you to enter a positive number and nothing happens. And then say we want to also change the number later. After you enter the positive number, we want to change it to a float. So float and then num. And as you can see right here, I just gotta explain this real quick. So this is a variable, and this is the input function, and this is what will ask you to enter. It will print this to ask you to enter a positive number, as you can see over here, and it will be stored in the number variable. And this is the input function, which will allow the program to accept user input, as we just did. So moving on, number will be stored as a float now, and moving on after that, number equals to abs num. So abs, if you know anything about cars or bodybuilding, it's not what you think. Abs is just the absolute value. So as you can see, return the absolute value of the argument. So whatever the number is, it will give you the positive, the opposite value of it. So if I put -1, it'll store it as 1, because the positive value is the absolute value of any number. And moving on, we can also round the number, and finally we will print the number. So let's run it. Enter a positive number, 5, and it'll return 5. But say if you enter A, it'll be wrong, because you cannot store an alphabet or something that's not a number inside of a float. So you run it again, 5.0, it's just 5. Why? Because it's an integer. So as you can see, it's taking up 1, 2, 3, 4, and 5 lines of code to finish up this simple little program that we have written. And there's an easy way to combine all of them together, and it's with the nested function calls. So to do that, we print, because that's the main function right here, and you have to know that the innermost is what will execute first, and we want to execute this, which is enter a positive number. Okay, but we also want to make it a float. So you add parentheses, float, and then parentheses, and you have to add one at the end as well. And then you also want to add the abs, so abs, and then here as well. And then you also want to add the round function. There we go. Okay, and there you have it. You run it. Wait, let me turn this into a comment first. You run it, and it's the same thing. Enter a positive number, 6. Okay, let's enter a negative number this time. -6, you still end up with 6 because it rounds up. I mean, because it takes the absolute value of it. And let's round. So enter a positive number, say 5.1, you'll get 5. Let's say 5.6, you'll get 6 because it rounds up. And that's basically what nested function calls are in Python. It's basically just taking a simple program of a couple lines and putting them all within one line. So here we have the input function. This is what we'll execute first. So sometimes the order matters, sometimes it doesn't. Like right here, it doesn't really matter because we're just, you can round first or you can take the absolute value. It doesn't matter. I mean, I guess it does matter in some situations, but in this situation right now, it doesn't really matter, right? So the order just be careful of the order because sometimes it matters. That's what I'm trying to say. So first, it's gonna accept user input, then it's gonna make it a float, it's gonna turn it into a float, and then it's gonna take the absolute value of it, and then it's gonna round it, and then it's going to print it. So thank you very much for watching and tuning in. If you learned something new or enjoyed this video, please like and subscribe, and stay tuned for more Python and computer science content. I do want to mention one more thing before I end this video, and it's that you need to make sure that it is a float if you're going to be using something with a decimal, right? Like right here, we have float. If we change it to int and we try to, let's stop it and run it again. Change it to int, and if we try to put something with a decimal, we get an error. But if we change it to a float and we run it again, it's fine. So you need to be careful of that. If you're going to be using decimals, you need to use float. If not, then it's okay. You can use int or integer, int or float. And one more thing, you also need to be careful to use int or float in the beginning, because if you don't, this is considered a string. So if you run this code and you put 5, you get an error because you're trying to perform a mathematical function onto a string. Okay, hello everyone, and welcome back to another video for Python. In this video, we're going to be making a simple calculator program. So as you can see, at first we declared the variable and we assigned it to this input, and it says please enter a valid operator, either addition, subtraction, multiplication, or division. So we need to store numbers as well. So num1 equals 2 and num2 equals 2. So we kind of have to do the same thing here, which is ask for an input here and here. And for the input, we need to say please enter enter the first number, and for the second one we say please enter the second number, and let's put a semicolon or a colon, sorry. And okay, if we run this, let's just make sure. Hold on. Current file, run, please enter a valid operator. It just doesn't do anything, but it stores it in this. Okay, great. So moving on. Okay, first we need to declare this as we need to declare this right here as a float, because we're going to be using division and multiplication, and we don't know if there's going to be decimal values or not. So we need to typecast it by surrounding it with the float, and same for this one. So float, and this is how you typecast in Python. Okay, moving on. So if the operator equals to, let's say we start with plus, okay, then we want to say result equals to num1 plus num2. Great. And then we want to print the result. So print result. Okay, so I accidentally put a semicolon instead of a colon. It's my bad, but that's just now it works. So if we print it, we say plus. Okay, please enter your first number. So that's 1 plus 2 equals 3. That's great. That's perfect. Okay, moving on. So we're going to say if, or elif, sorry, the operator is a minus sign, then we want to do result equals num1 minus num2. And then we want to print the result. Okay, what's going on here? Oh, I forgot to add the equal sign, sorry. Okay, so minus, and let's say 3 minus 2, that's 1. Okay, perfect, perfect. Everything is working as expected. Okay, so elif operator equal, and we're gonna say multiplication. Then we want to make the result be num1 times num2, and then we want to, of course, print the result. Okay, let's try it again. 2 times 3 equals 6. Okay, perfect. Okay, last but not least, we say elif operator equal, and that's division. Then we want to make num1 divided by num2, and we want to set that equal to the result, and then we want to print the result. Oops, okay. So let's say division 6 divided by 2 should be 3. Okay, perfect. Okay, and of course we need an else statement, because what if the user doesn't input any of these? We need to find a way to catch that error, which is, instead of just keep going, so else print this is an invalid operator, please try again. So if we input something stupid like this, invalid operator, please try again. Okay, great. Now we need to make some quick changes here and there just to make it a little cleaner and better and work better. So for example, let's say right here, if we say for division, okay, first let me just make a space right here, that should make it better. So division, let's say the first number is 5, second number is 2, that's 2.5, so that's great. But if we say some random number like this, oh wait, no, sorry, division, and then some random number like that, and then we divide it by, let's say 7, I hope is good. Okay, cool. Okay, as you can see right here, there's a lot of decimal places. So if we want to round it, we can make a good little change right here for this, for the division, which is print the rounded function. We add the round function to the result. And as you can see, it's rounded. But what if we want the, because this rounds it to the nearest integer. So what if we want to round it to the nearest, 3 decimal places? Okay, so you do the same thing, except here you add a 3. So if you do the same thing again, 7, as you can see, you get 3 decimal places and the rest are excluded. And, just for clean purposes, we can just replace all of this with it, just in case you have some kind of you know, when you're multiplying, you have some kind of decimals or something, you can also round that as well. So another change we can make is the printf. So with printf, you can say printf, and then here you would specify that the operator is an invalid operator. Okay, so here W is an invalid operator. Instead of saying this is an invalid operator, it tells you exactly what you wrote and it tells you that it's invalid, which makes it a lot better. Okay, and that's pretty much basically it. We have a simple calculator program with one variable for the operator, one variable for the first number, one for the second number, and then you can add, subtract, multiply, or divide, and you have kind of like an error handling line, kind of, you could say. And that's pretty much it. I'll see you guys in the next one. Hello everyone, and welcome back to another video. In this video we're going to be talking about exception handling in Python. So an exception is an event or error that interrupts and stops the flow of a program abruptly. So as you can see right here, we have a simple program, and anytime you have some kind of code that might result in an error, you want to surround it with a try and with a try block, and that stops it from abruptly, you know, stopping the program, because it will catch the error. So you catch the error in these except blocks and you try the code first. If it works, it works. If it doesn't, then you catch it in the except blocks. So in Java it's try and catch, but in Python it's try and accept. So I have a simple program right here. We have a numerator, and it takes user input and casts it to an integer, and then same thing with the denominator, and then finally the result is the numerator divided by the denominator. And dividing by 0 is commonly like known, like in math, that it just completely doesn't work. So this is the easiest and most simple program I could come up with to help us understand this topic. So we have a numerator divided by the denominator, and it's going to be stored in the result variable. So if you have, let's say, if you run the code and you have a numerator, say 1 divided by 0, that would result in an error. So you want to catch that error. So if we delete this and this, and we enter numerator 1, denominator 0, we have a 0 division error, which means that we are dividing by 0, and you can't have that. So if we go back to this, we can catch this error and make it not stop this program, because you can see, like right here, it's just stopped the whole program, and if there was more code, then it would never execute, because this would be an error. So whenever you have user input, you typically want to do this, because you never know what the user might you know, put, and if it's something that you know might cause a problem, then you want to try to catch as many of those as you can. So to catch any normal error, that like any error at all, you want to say except, and then in the except block you say exception, except exception, and here you want to print just something general, because you don't know what the user inputted. So there has been an error, please try again. So if we try again, 1 divided by 0, there has been an error, please try again. But we know that you can't divide by 0, so typically you want to you know, try to show what kind of error has been detected. So we want to add another accept block, and we want to accept the 0 division error. And when this happens, we want to print you cannot divide by 0. So if we try again, 1 divided by 0, you can't divide by 0. If we say 1 divided by any words, then it just detects it here. But we want to say that you can't use words, you need to use an integer. So we do the same thing, because this is a value error. So we say accept value error, and then we say print please enter a valid integer. One divided by words, and please enter a valid integer. Okay, moving on. And if you want to display what kind of error has been detected, you want to say as e, and then here you want to print e. So you can do the same thing here and here, and of course we need to say as e, and here we say as e. And this way, 1 divided by 0, division by 0, this is the error, you cannot divide by 0. So the same thing will happen with 1 divided by words, invalid literal for int with base 10. So it's basically telling you that it's not a integer with base 10. Okay, moving on. Another thing is you should have an else statement, so that if this code does execute, if there are no errors, then we want to print, what do we want to print? We want to print the result. So 3, I pressed enter by accident. 3 divided by 1 is 3. Okay, and then you can also, this is strictly optional, but you can say finally, and this will always execute no matter what. You can say print thank you for using my program. So this will always execute no matter what. Like if we start it and say 1 divided by 0, it tells you what kind of error it is, it tells you the print statement that we put, and it tells you thank you for using my program. That's if it doesn't work. And if it does work, then it still gives you the answer and it tells you thank you for using my program. So that's basically exception handling in Python. It's pretty simple. You can use this for a number of different things. And if you learned something new or enjoyed this video, please like and subscribe, and I'll see you guys in the next one. Hello everyone, and welcome back to another video. In this video we're going to be talking about math functions in Python. So of course you need to start off by importing the math library, and then I have a couple variables to help us with some examples, and I have a couple examples that I want to show you. So let's start off with the first one. We need to round the variable or the number. So we want to print, let's say, round and g. And when we run this file, it runs it to 10 because 9.81 is closer to 10. So if we say 9.1, I should make this bigger actually. It'll round it to 9 because it's closer to 9. But we want to keep it as 9.81 because that's the gravitational force of the Earth. But yeah, okay, cool. So now we want to round up. If we want to round up, because sometimes you don't just want to round to the nearest integer, sometimes you want to round up all the time. So same thing, you would say print, and then you use the math function math.ceil, which stands for ceiling of g, and that basically always rounds the number up. The ceiling function always rounds it up, as you can see here. Okay, cool. Now, of course, the opposite of the ceiling is the floor. So if we want to round down, you do the same thing but with floor. And if you run it, you get 9. It could be 9.99 and it'll still be 9 because you're taking the floor of it. So yeah, okay, next, finding the absolute value. The absolute value, as you know, is basically like, even if it's negative, you will always just get the number without the positive or negative sign. It'll always be positive. So to get the absolute value of it, you just need to get so print, and here you would say ABS, and there you go, 9.81. You always get the absolute value, even if it's, let's say, negative 9.81, it still stays. As you can see, all of these change to negative, but this one is still positive. So that's it for the absolute value. Next, we have the power of 2 or more. So if you want, you can multiply a number with its power. So we want to print math, or sorry, not math, but we want to print pow, which stands for power. And as you can see here, this is the base and this is the exponent. So we have the base, which is, say, g, and the exponent is 2. So g times g, and it'll be this much. Let's use an easier one so it's easier to calculate. Let's say 12, okay, which is b. B squared should be 144. Yeah, that's correct. And if you multiply it 3 times, so to the power of 3, it's this much, and you get the point. Okay, square root of a number. So we did the power, and we need to do square root, which is the opposite. So to get the square root, it's pretty simple. Math dot sqrt, and you get the square root of g. So that would be 3.13 and so on. Okay, cool. Finding the largest of a collection. So right here we have a collection, A, B, and C. There's the smallest one, which is 1, and there's the biggest one, which is 1, 2, 3. So to find the least, or to find the largest, sorry, not the least, we say print max, and then we give our variables. So A, B, and C. So we have, which one is the max? The max is 1, 2, 3. And if you do want to find the smallest of a collection, it's the exact same but opposite. So instead of max, you use min, and you run it, and the answer is 1. And that's pretty much it for math functions in Python. If you enjoyed this video or learned something new, please like and subscribe, and of course the whole full code will be posted in the comments down below, and I'll see you guys in the next one. Welcome back to another video. In this video we're going to be talking about string formatting. So string formatting is an optional method that gives users more control when displaying output. So I have 2 variables here. One is an animal, one is an item. We have a frog, which is the animal, and the item is the pad. It's supposed to be lily pad, but I'm too lazy to write lily pad every time, so just pad and you get the point. Okay, so this is like the normal easy way to print it out. The animal jumped over the item, and then when you run the code, you get the frog jumped over the pad. But what if we don't want that? What if we want to do something else, which is string formatting? So there's one way you can do it, which is with a print statement that looks something like this. So the, okay, jumped, and then the curly braces jumped over the, and then curly braces again. And then after that, before you close it, you put format, and then we have dot format, and then inside the parentheses we have animal and item. And as you can see here, if we run this code, we get the same thing. The way it works is with the first set of curly braces, we get animal, inputted into here, and then with the second one we have that. So if we switch item and animal, it would look something like this. The pad jumped over the frog, but we don't want that. We want it to be animal jumps over the item. Okay, cool. There's another way you can do this with it, which is with positional arguments. And I think I made a video about this before, but we can touch up on it a little bit more. And it's the same thing, and then curly braces, and then in here you do 0, and this will make more sense in a bit. Jumped, I can't type today, I'm sorry, over the, and then curly braces again, or sorry, 1, this is supposed to be 1, and dot format to call the method, and then this is supposed to be outside, I'm sorry, dot format animal comma item. Okay, so this is positional arguments. And what would this look like? The same thing. You see right here, 0 is for the index 0, and 1 is for the index 1. So if we switch these again, let's see what happens. You guessed it, it's the opposite. But if we keep them the same, but we change the index, then you guessed it, the same thing happens. Because now we're putting the index 1 first, which is item, and then the animal second, which is frog. So we don't want that. We want to keep it as 0 then 1, not 1 then 0, because that's, yeah. Okay, moving on. There is a third way to do this, and it's print. I should just actually just copy this, and that would make it a lot simpler. Print the, and then instead of 0, you would put animal jumped over the item. And here you would put dot format animal is equal to frog, and item is equal to pad. And of course you need to surround this with double quotes, and the same thing happens. It's just that instead of positional arguments here, we used keyword arguments, which is another thing that I've talked about in another video, but you can watch that on your own time sometime later. But this is keyword arguments, and this is right here is positional arguments. Okay, moving on. Let me just get that little thing out the way. Okay, so there is a couple more things I want to discuss. So here we have text equals, and then that. Okay, so this is the text variable right here, and this is being stored in it. So we want to print text dot format, and inside the format we want to do animal item. So this is the same exact thing, it's just a different way of putting it. You can, if one of these ways works best for you, you can use it. If this way works best for you, you can use this as well. Personally, I prefer one of these because this is just kind of confusing. But here we have the text variable, and we have the two sets of curly braces. And the first one, as you can see, the text format is going to be animal then item. So if we run this, it's going to be animal then item. And as you can see, this is 1 2 3 4 5, and this is 1 2 3 4 5. And yeah, that's basically it for string formatting, but that was a lie. There's more to it. So let's talk about it some more. So there's name, and my name is Yusuf, so Yusuf, and you can say something like print hello, my name is and then dot format name. Why did that not work? Oh, I forgot the curly braces. Oops. There we go. Rookie mistake, I'm sorry. Okay, so there is another thing that you can do. Another thing that I want to talk about, two more things actually. One is something called padding, and this is with strings. And then there's a couple string formatting techniques I want to touch up on, but they're for numbers, not strings. So for padding, here we have using padding. Let me just make that clear. Okay, we have print. Okay, so padding. As you can see, it's pretty clear. Hello, my name is Yusuf, and then there's about 10 spaces right here. Or no, sorry, not 10 spaces. 1, 2, 3, 4. Okay, 4 spaces, and my name, sorry, not my number, is 6 letters. So 6 plus 4 is 10. And as you can see right here, we have 10. Okay, so there's two different things I want to show you with this padding technique. And the first one is if you replace the 10 with, or not replace it, sorry, but add the greater than sign to it. And the same thing, but the opposite here, the less than sign, or sorry, the less than sign and then the greater than sign, you have something else, which is here. This is the same, like the second one is the same thing as the first one, but here this reverses it. So basically the padding now is the 4 letters in the beginning of the word, and that's the padding, that's the empty spaces, and then the word starts after. But for these two, it's the same thing. It's the word first, and then like the last amount of padding. But if you want, you can make the padding less, or like if I make it 6, you can see right here that there's no padding at all because it's 6 letters. If I make it, like, let's say 25, it'll be a lot more. This is 19. You can count that on your own. These are 19 spaces plus the 6 from my name, so that's 25. But we don't need that, that's a bit too much. We can just leave it at 10. Okay, we're finally done with the string formatting. Now we can move on to numbers. So let me just make 2 numbers right here. So the first number is 1.23456, and the second one can be num2. Let's just make this num1 and num2, or just num. We don't need num1. Okay, and then we can call this let's say 1000. Okay, so the first thing we want to do is display the first 2 decimal points of this number. So we say print number is, and then we can say, again, curly braces are the most important thing, and I keep forgetting them, but this is where it goes. So we want to say colon dot 2f dot format num. Okay, and it works. So let me just explain it real quick. Number is, this is just normal string, and then colon. After the colon, we want to say dot 2f. So this stands for, dot is for the decimal, and then 2, or no, sorry, not decimal, but what comes after the numbers, which is the decimal, of course, and then 2, so 2 places of the floating point floating points, two floating points. So this is two decimals. So after the decimal, we have 1, 2. So it's going to be 1.23. That's great. Okay, moving on. Now we want to display a comma after every 1000's place. So print let me just copy this, and we want to say for this it's going to be number 2 because this is the one with the thousands place, and number is, and then we want to do that. And as you can see, it works. If I change this to 1 million, then it'll still work. As you can see, every 1000 it adds a point, or a decimal, sorry. So that's good. Okay, next we want to convert the number to binary. Now this is very important. If you're a computer science student, you'd be using this a lot. Okay, so print, and then we want to say inside the print, we want to say the number, or sorry, let me just keep it consistent. Number is curly braces, of course, not normal, and curly braces, and inside the curly braces we want to say colon B, and then of course dot format number, and we want to be using number 2 for this because number 1 is just weird and it's hard to convert it to binary because, you know, decimal. So run it, and this is the binary of this. And if let's just change it to make it a bit simpler. So let's say, what's a number that we all know in binary? So we have 2, 4, 8. So let's say 8. That's right. 4. Yes, sir. That's right. Okay, let's say 3. Should be 1, 1. Yeah, that's right. Okay. So let's just go back to 1 million. I think that's a million. Okay, cool. Let's go to the next one. And of course, if you're going to be dealing with binary, there are times where you're going to be dealing with octal. So if you want to, you know, if you want to convert it to octal, you can do the same thing, except instead of the B, you just put an O, and that is the octal version of 1 million. Okay, what's next? Next is, of course, hexadecimal. So hexadecimal, we want to do the same thing, but instead of the O, we change it to X. And this is the hexadecimal format. Easy peasy. And of course, if we want to convert it to the scientific notation, we can do the same thing with capital E. And this is it. And if we change it to, let's say, back to 1000, then this is it. You get 1.0000 with plus 03, so 3 zeros. And that is basically it for string formatting in Python. I hope you enjoyed today's video, and I hope you learned something new. This looks like a lot, but it's actually really simple, and with more practice you can see that it's really easy. So I hope you guys enjoyed today's video. Please like and subscribe, and I will see you in the next one. Hello everyone, and welcome back to another video. In this video we're going to be talking about 2D lists in Python. So 2D lists are very simple. Don't let the name discourage you. Here we have 3 lists, and as you know, lists use square brackets. Okay, so muscle cars, we have a Camaro, Mustang, and Challenger. Trucks, we have a Sierra, Raptor, and TRX. Sport cars, we have Corvette, Ford GT, and Viper. So there's 2 ways we can go about this. or there's one way, but then we can use two ways. But we have a cars variable, and in the cars variable, we're gonna make a list, and inside the list, we're gonna have muscle cars, and we're gonna have our truck variable, and we're gonna have our sport variable slash list. Okay, cool. So when you move on to print, we want to print cars. So if we print cars, it's gonna print everything. It's gonna print every list within this list. Okay, but if we specify cars with an index of 0, it's gonna display the first list of that list. So the first list is muscle. So if we change it to truck, which is 1, okay, it's gonna print all the trucks. And same for number 2. It's gonna print all the sport cars. Cool. Now if we specify another index, this might get confusing, but it actually makes sense if you think about it. Let's say 2 and 0. Corvette. Now how does that work? We have 0, 1, 2. So the first index is 2, and which is sport. And in that we have 0. So 0. So 2 and 0 means this. It's basically like kind of like a matrix if you kind of think about it. So if we change it around and say, let's say 1 and 2, it's gonna go down to truck, and from truck it's gonna print not Sierra, not Raptor, but TRX, because it's gonna 0, 1, 2, which is TRX. So it's gonna print TRX. And that's basically it for lists in Python, or 2D lists I should say. If you like this video, please like and subscribe, and of course, as always, the full code will be posted in the comments down below. Hello everyone, and welcome back to another Python video. In this video we're going to be talking about string slicing in Python. So string slicing is basically just creating a substring or extracting elements from another string. And you can use indexing or slicing. Both have their own uses. And this little part right here will make sense with a few examples, but basically to know what you're going to use, especially in slicing or in indexing, you start, the first part is the start, and then it's the stop, and then it's the step. And let's start with a few examples. So basically here I have a name, and this is my name, Yusuf Al-Hamid, and in this name we're gonna be slicing with indexing. So here it goes. So if we want to extract the f name first, which is the first name only, I mean, then we do name, and then inside these brackets we would put :6. Why the number 6? Well, because my name is 6 letters, so we're going to be extracting everything from, if this is empty, it's basically from 0, so from 0 all the way up to 6. So if we say print fname and we run this code, or I should run this current file, if you run this code you get Yusuf. If we say 10 for example, then it'll be the first 10 letters, which will be up to like around here or something. So as you can see, it's all the way up to here. This is 10. You can count for yourself, but yeah. Okay, so let's change that back to 6. So, and same goes if we want to extract the last name, but in reverse. So lname equals name, and then inside the brackets we would put 7 and then colon, which means we're going to be starting from, this is 6 and then 7, so from the 7th one up to the end. So if we run it, then we get my last name only. Cool. Okay, let's do another thing just to, get you a little more familiar with it. With this part especially, we have a funky name. A funky name equals name, and then inside the name we would put : 2. Now you might think this is weird and it doesn't make sense, but let me show you with an example first, and then it'll make more sense. So as you can see, this doesn't really make any sense, but if you go here to my name and you start counting, this is 0, 0, and this is 2. So the start is at 0, and the stop, it's not, or it's, I shouldn't say 0, I should just say unidentified. So the start would start at the beginning, stop would stop at the end, and the step is 2. So we start at the first one. So what's to the right of it? It's y. So here we would put y, and then we would go 1, 2, and then to the right of that is u, so we put u. 1, 2, e. As you can see, y, u, e. And then after the e, 1, 2, space, so we put space, and then 1, 2, l, so we put l, 1, 2, so we put a, and then 1, 2 again, a, and then 1, 2, and it's the end. And you could say this is blank, so it's not there. As you can see, like, there's no space right here. So that's it for the funky name. If you change it to 3, then it'll skip 3. As you can see, starts off with y, and then 1, 2, 3, so s, 1, 2, 3, so space, 1, 2, 3, h, 1, 2, 3, a, and so on and so forth. But yeah, let's change that back to 2. And then last but not least, this is very important, but reversed name. So you need to know how to reverse a string, and this is a very easy way to do it in Python. So to reverse the name, you just put name, and then it's the same thing, but same thing, but it's -1 at the end. So we start at the beginning and we work our way, or at the end, sorry, and we work our way down to the beginning. And to see what that looks like, as you can see, it's in reverse. Okay, so that's it for indexing. Now we're going to start with slicing. And slicing is pretty much simple and straightforward. In my opinion, it's kind of even simpler than indexing, but it's just my personal opinion. So let's say we have two websites, right? Okay, so we have two websites. Website number one is youtube.com, www.youtube.com, and the second one is www.yusufalhamid.com. You can actually check this out. It's a real website. That's where my personal portfolio is, and I will be updating it more and more with time, but as for now, it's just a very simple portfolio. But so we have a slice variable, and in the slice variable we have the slice function, and within the slice function we want to input how much we want to slice. So the first number is from the beginning and the last number is from the end. So if we say 4 comma minus 4, and then we say print website 1 slice. Okay, so right here, let me just show you what would happen first. So right here you have YouTube only, and let's do it for the second one, and same thing, Yusuf Alhamid only. So you don't have the www dot and you don't have the .com at the end. This is string slicing, and it's pretty simple. Here we have 4 and minus 4. So how much do we want to cut out from the beginning? 4, which is 1, 2, 3, 4 letters, or characters I should say, and then from the end, same thing, 1, 2, 3, 4. And this goes for any string of any length. As you can see, this is a different length than this right here, but it still works for both of them because it works by counting from the beginning and from the end. And that's basically it for string slicing in Python. I hope you enjoyed this video and learned something new. If you don't mind, please like and subscribe, and stay tuned for more computer science content. And of course, the whole code will be listed in the comments down below. Okay, so nested function calls. Nested function calls are basically functions inside functions. So to make sense of that, we're gonna use an example as always, but two things you need to know is, one, the innermost function calls are resolved first, which means it's from right to left. And second thing is, returned value is used as an argument for the next outer function. So if this is a function and this is a function, it's going to return this value and it's going to use it here for this function. So let's use an example to help us understand. So here's a function that I'm going to be writing. So we have a variable num, and it's going to be taking the input of this little print statement. So it's going to tell you to enter a positive number. If you enter a positive number, it does nothing. Cool. Okay, so we want to say num equals to float num. So what this does is, this is basically type casting. So you've seen it before where we do float and then we surround it with parentheses, but this is I guess you could say this is an example of a nested function call, but to do it not nested, this is the normal way. Okay, so moving on, let me just do more before I run this code. You can say num equals to ABS and num. So ABS stands for absolute value, not anti-braking system if you're into cars, but yeah. Okay, next one we can say num equals to round and num. So what this is going to do is it's going to take the input of this, enter a positive number, we're going to enter a positive number, it's going to store it in num, and then we're going to convert it to a float, and then we're going to take the absolute value of it and we're going to store it in num, and then we're going to round it and store it in num. So last but not least, we want to print num. Cool. So enter a positive number, we can say 2, sorry, and it gives you 2. If you say 4.5, it returns 4 because it's rounding and it's taking the absolute value and it's taking the float. So it accepts a float, but it'll still round it at the end. And if, let's say, the person doesn't listen and enters a negative number, it'll still return a positive number because we asked for a positive number only, not negative. Okay, so here is how you would do the same function but in a nested format. You want to say print, and then within print, what do we want to do first? We want to convert it to a float. So float, and inside float we want to input, and inside the input we want to say enter a positive number. And let me just comment this out. Cool. Okay, so right now we have print, float, input. So now this is going to execute first, and then this, and then this. But let's keep it going and add the rest, which is ABS and round. So we're going to say ABS, and you need to close it off at the end, and also round, and again close it off at the end and surround the whole function with the parentheses. So as you can see right here, from right to left, we start with the input function, then float, then ABS, then round, then print. And as you can see from right to left, it's going to be using the returned value as an argument for the outer function, and then the outer function, and then the outer function, and it just keeps going until the end. So if you run this code, it'll do the same thing as the previous code. Enter a positive number, 3, it returns 3. 3.5, it returns 4 because it's rounding up. And if you do negative 3.5, then it'll still convert it to 4. Because first we're taking the absolute value of it, which is 3.5, and then we're rounding it up. So that's basically it for nested function calls in Python. If you like this video or learned something new, please like and subscribe. I have a lot more computer science content coming, not just Python. And as always, the full code will be in the comments down below. Welcome back to another video. In this video, we're going to be talking about reading a file in Python. So to read a file, it's pretty simple. First, you must have a file, of course, in order to read it. So if you refer back to my previous video, I made these two folders, or these two files. One is a folder, one is a text file. And I said you should right click, press properties, and then copy this to get the exact location, and when you get the location of it, you come here and you paste it in order to use it. So we have it here in a comment just for easier access, and I also said, just a quick note, you need to use double slashes, not one, because if you use one, it creates a problem. So to read a file, we want to use and try and catch block, because if the file does not exist, then it will cause a problem and an error, and that's not good. So we need to use try and except blocks, which is exception handling, and I talked about that in a previous video, as you can see right here. If you want, you can check that out. But we have a try block. Inside the try block, we want to say with open to open the file, and then we want to read it. So with open, we want to say that, which is the exact file location of this text file, sorry, and we want to say as file because it's a file, and we want to print file.read because that's how you read a file. Moving on, and we want to, of course, use an except block. So except file exists error, or sorry, file not found error. I kind of rushed that, but yeah, file not found error. That's the kind of error you would get if you did not use a try and except block, which is again exception handling. That's why exception handling is important, so it doesn't interrupt the flow of a program. So we're gonna print the file was not found. Okay, so let's run the code. As you can see, the file exists, and this is what it says. If I go to example and I open it, that's what it says. If I change it here, let's say add something, save it, exit out, and we run it again, it reads it. If, let's say for example, we change it to another file name, text1, the file was not found. And if we don't have a try and except block, then you would get a file not found error, which will completely disrupt the flow of the program and interrupt it, and that won't be good, and you'll get a bunch of red font here that's saying you did something wrong. So that's it for today's video about reading files in Python. If you learned something new or enjoyed this video, please like and subscribe, and I'll see you guys in the next one. And as always, the full comment will be posted in the comments down below. Hello and welcome back to another video. In this video we're going to be talking about file detection in Python. So file detection is basically, just like it is in the name, it's to detect a file. So here in my desktop I have a folder named example. Inside the folder named example I have two things. One is a text file called text, and one is a folder called folder. So if you right click on it and go to properties, you can see the location, also known as the path. And same thing for this one, right click, go to properties, you have the path. So if you copy paste it here, it'll take you to, it'll give you this, and then you add in the example folder that is in the desktop, and you add in the file you want to look at. And you have to use double, I forgot what these are called, double slashes. It's going to give you single slashes, but you're just going to have to add a slash because that's just how it is in Python. So we have two paths. One is for the text folder, sorry, and one is for the folder. Cool. So we want to detect first if it's there or not. So if os.path, oh, and I forgot you have to import the OS, which stands for operating system. So if os.path dot exists, and you give it the path, which is path1, which is right here. If it exists, what do we want to do? We want to print this file exists. Cool. And inside that if statement, we want to write another if statement, which is if os dot, oh sorry, if os dot path dot is file path You have to add in the path 1 as an argument. Then what do we want to do? We want to print that is a file. Okay, so what this is doing, let me just explain briefly. If os.path.exists, so this is checking if the path exists. Print the file exists, or the path, sorry, the location, I should say. It exists. If it doesn't exist, it's going to move to the else statement, but we don't have an else statement right now. We have an ested if statement, and we're going to check before we move to the else statement right here if the path is a file or not. So maybe it's a location, yes, but it's not a file. So we're going to check if it's a file, and then we're going to print that it's a file. So let's do that. This location exists, that is a file. Okay, cool. Now let's change it to path2. Or actually path2 won't do anything, but let's add an else if statement. Else if os.path is dir. Dir stands for directory. And then we're going to add in the path argument, path1. We want to print it is a directory. Let's run it again. This file exists. Oh, I forgot to add the dot here. Sorry. Oops. Okay, cool. That is a file and it exists and everything is cool, but it's not executing this. Why? Because it's a text folder, or a text file, sorry, not a folder, not a directory. So if we change it to path2, sorry, I forgot to do it here as well. Path2. Okay, so I made a little bit of a mistake. I had the .dir here, but you're not supposed to have that. So just put folder for if it's a folder, and it should work. Okay, so first let me run it back again. If os path exists for path2, which is the folder, as you know, it's gonna check these two, or it's gonna enter the inner loop. Cool. If os path is a file, then it's gonna print it's a file. If it's not a file, it's gonna move to the else if statement, which is if it's a directory. So it is a directory because a folder is basically a directory, then it's gonna print it is a directory, as you can see right here. If we change it to path1, then it prints out it's a file, not a directory. Okay, cool. And then finally we have the else statement, which is gonna print that location doesn't exist. So if I change it to we have path1, so I guess I can say text1. It's gonna say it doesn't exist because there's no such thing as text1 in my folder. And that's basically it for file detection in Python. I hope you enjoyed today's video, and I hope you learned something new. If you did, please like and subscribe, and stay tuned for more computer science content. And as always, the full code will be posted in the comments down below. Hello and welcome back to another video. In this video we're going to be talking about how to write a file in Python. So here we have some text. Please like and subscribe. And here we have the folder of these what's it called, Python files, and as you can see, this is the path for it, and it contains these files, which you can see right here. So if we exit out of that and we type with open, and then we say, let's give it a name, let's say name, let me move out of the way, okay, name, and of course .txt, and comma W, and W will make a lot of sense, but for now just bear with me, as file, and then we want to say file dot write text. And that's it. Simple as that. We run the file, and as you can see, it added it. And if we run it again, nothing happens, but it's just, it added it. Okay, now we have a problem. It says right here, please like and subscribe. If we open it, it says, please like and subscribe. That's great. But if we change it to and hi, we run it, it says and hi. Okay, now it's changing it, but that's a problem, because what if we change it to, what if we completely delete this and we run it, then it'll just say hi, and we don't want that. We want to add to it. So to fix that, what do? We change the W to A. Simple as that. As you can see, it added it to the end. And if we go back here and we run it a couple more times, then it just kept adding more and more and more. Why? I'll tell you why. Because W stands for write, and A stands for append. Appending in Python is basically just adding to the end. So if you have some text here and you append to it, then you start typing at the end of it. But writing is completely ditching the old text and overwriting it with something else. And it just depends on what you want. Do you want to overwrite the text, or do you want to append and add to it? That's when you know you should use W or A. Also, another thing you want to keep in mind is here we have name.txt, and that's how we're adding something. But you can open a file that already exists by using this little thing right here, which is going to that specific file, right-clicking on it, getting the properties, and when you get the properties, you copy the location of that text file and you insert it here, and it would work just the same way. You can open it and then append to it, or write, or overwrite it, I should say. But that's basically how you write a file in Python. If you enjoyed this video or learned something new, please like and subscribe. And as always, the full code will be posted in the comments down below. Hello and welcome back to yet another video. In this video we're talking about copying files in Python. So copying a file. In order to copy a file, you need a certain library, but in my case I'm going to be using Shuttle. So I'm going to be using Shuttle, and in Shuttle you have three different methods. You have copy file, copy, and copy to. So copy file just copies the contents of a file. Copy does the same as the first one, but it also copies the permission mode, and the destination can be a directory. Copy to does the same thing as copy one, which does all of this, but it also copies the metadata of the file. So the metadata basically means the data about the data. So the file's creation time and modification time, and when it was last accessed, and all the data about that certain file basically. So here we have the import shuttle, and after that we can use one of the three methods. Okay, so first use shuttle dot copy file, and like I said, you can use copy file, or copy to. We're going to be using copy file, and in here you basically have two arguments. First argument is the source, and the second argument is going to be the destination. Cool. So what's the source? The source is this right here. We have this text file in our project folder, and it's name.txt. It says hi, please like and subscribe. So we're gonna say name.txt. So that's the first argument, and the second argument we're gonna name the new text file that we want to use, which is, let's say, name2.txt. And if we run it, then As you can see, the process finished and this popped up and it says the same thing. Hi, please like and subscribe, just like the first one. And for this one, and if you want, you can also use copy to. It's the same thing. And there you go, it worked. But you can just rename it, name 3 just to make sure it works, and it works. And that's basically it. You can also use the path file, the path of the file, sorry, instead of the name of the file, because right now the file is in the project folder, so we don't need to specify the path of the file. But if it was somewhere in my desktop or something like that, then we would need to do the same thing that we did in the other examples, the other videos that I've covered before, which is specifying the specific file path, like this right here, or this right here. Doing that just basically ensures that you are going to be putting everything where you want to put it instead of in the same project folder. So that's it for copying files in Python. If you enjoyed this video, please like and subscribe, and stay tuned for more computer science content. And as always, the full code will be in the comments down below. Hello and welcome back to yet another video. In this video, we're going to be talking about moving files in Python. So to do this, you're going to need to import the OS module, which is in the normal standard Python library. And you're going to need 2 variables. One is the source variable, which is going to indicate what and from where you're moving the file from, and to the destination. So this is from and this is to. Okay. To do this, we're going to need to specify what the source is. So if the source is already in your project folder, this is the project folder that I'm using right now to write this code. If it was already here, then I don't need to specify the file path. If it wasn't here, if it was anywhere else in my computer, then I would need to specify the file path. In this example, we have name1.txt. So name1.txt is the source, and we want to move it outside. And to move it outside, we want to move it to, let's say, the Python project library, or project folder. I can also move it to anywhere else in my computer if I want, but this is my example. And to do this, you just copy the source, the file path, and in the file path you specify what the name you want it to be. So right now I have name1.txt, that's what it's called. If I want to move it, I can just keep it as the same thing, name1.txt, and then we can proceed with the actual code of moving the file. So first, we want to surround this code with a try and except block, because if the file is not found, it will throw an error, and if it throws an error, it's going to completely interrupt the flow of the program, and it's going to give you a lot of red and ugly warnings. So we use a try and except. Okay, inside the try and except block, we want to first check if the file exists. So we say if os.path.exists, and then we specify the path, which is, if we want to say if it's in the destination, then we want to tell the user that it's already there in the destination. So print this file already exists. Okay, but if it's not, then we actually can do something, which is the else part of the statement, and we say os.replace source destination. These are the 2 arguments we're going to use. Source is going to replace whatever is in the destination, and if it's not there, of course, it's going to be moved there. And then we say print source was moved. And that's it for the try block. So for the except block, this is where you would put your error. So we want to accept the file not found error, and inside that we want to say print source to tell you that the source, which is the variable that we're using, was not found. Great. And of course you can do this with directories or files, it doesn't matter, but in this example we're going to be using normal txt files. Okay, so if I run this, it's gonna move this file from here to around here somewhere in that folder. And as you can see, it's been moved. Now if we want to move it back, again, we need to switch things around. We need to put this here, and inside here, we want to specify the file path. The file path or the file name. If we want to keep it in the same folder, then of course we just use the file name. So the file name, we can rename it to be rename.txt. And if we run it, it'll move it from here to here, and it'll be renamed, and it's the same file, as you can tell. And like I said, you can do it with folders as well. So let's try it with a folder. And as you can see right here, it tells you the exact path or the exact name of the variable, and it tells you that it's been moved. Okay, let's try it with a directory. So let's make a directory here, and let's move it. First, let's make a directory and call it dir, and it's here. And we want to move it from here to here. So to do that, it's literally the same thing. We call it that, and we say here dir, and it's actually in the tutorials folder, so we need to specify tutorials and then dir, and inside dir, and then that's the destination, or sorry, that's the source, and the destination, we want to move it to just Python project 1. So we just delete all of this, and we want to call it dir2. And as you can see, it's not here anymore, but it's here, and it worked, and it tells you that it was moved. So that's basically it for moving files in Python. I hope you enjoyed this video and learned something new. If you did, please like and subscribe. And as always, this code will be posted in the comments down below. I hope you learned something new, and I'll see you guys in the next one. Welcome back to yet another video. In this video, we're going to be talking about deleting files in Python. So in order to delete a file, you need the OS module, which is included in the standard Python library, and you can specify the name in here, which you want to delete. So here we have the delete me text file right here, and we can just specify it here, or we can store this inside a variable just to make things a little more clean. And in here we just call that variable, and if we run this file, as you can see, it got deleted. It's not there anymore. You can do this to delete text files, as you just saw, or you can also use it to delete directories, also known as folders. And directories and folders are a little bit more complex than that because they don't always work as easily, and you'll see that here. So if you want to remove a non-empty folder, as you can see, this one has something in it, it's going to be a problem. But before we do that, let me just show you what would happen if you tried to delete something that doesn't exist. So if it's not found, you will encounter a file not found error, which is a problem, and it'll interrupt the flow of your program. So to fix that, you need a try and accept block, just in case the path is misspelled or it's not there in the first place. So let's use a try and accept block. So try os.remove path. So we're going to try that. If it works, it works. If not, then we want to accept that it might not be found, and we're going to accept the file not found error, and then we print that it hasn't been found. So if we try it again, it just tells you that it was not found. Okay, so now when I try to do something else, which is try to delete the empty folder, we have a problem right here. I put the empty folder in the path, and it says access is denied. Why is it denied? Because you can't exactly choose or use this function to remove or delete this, to delete a folder. So in order to handle this exception, we want to say except, and inside the except block we say permission error, because that's the kind of error it is, and then we say print access denied. And if we try it again, access denied. And to fix that, we need to do one thing, and it's very simple, and we just specify os.rmdir, which stands for remove directory. As you can see, it was deleted. As soon as I commented this out and used this instead, it was deleted. Now we want to try one more thing, and it is to delete a non-empty folder. As you can see, this one has a hi.txt file in it that's empty, but that doesn't matter. The folder itself is not empty. So if we change the path to a non-empty folder and we try to remove the directory, we get another error which says OS error, the directory is not empty. So we need to handle that exception. How do we handle that exception? Same as before, except OS error, and we need to print folder is not empty. And if we run it, as you can see, the exception has been handled, but the problem is still there. So how do we fix the problem? To handle this problem and to remove the directory, we need to use another thing, which is something from the shuttle library, or the shuttle module, I should say. And what we use is shuttle.rmtree, and we specify the path. What does that do, or what does that stand for? rmtree stands for remove tree, which means kind of like the tree of, you know how trees are, you have the root and the nodes. So this is a node, so this removes the whole tree. So in order to do that, you run it, and as you can see, it was removed. Now this is considered dangerous because, as you know, it will remove the whole tree and everything in it, so be careful when you use that. But that's basically it for removing or deleting files in Python. I hope you learned something new. If you did, please like and subscribe, and stay tuned for more computer science content. And of course, as always, this code will be posted in the comments down below. What is up, YouTube? This is another video in Python talking about modules. And a module is basically a file containing Python code, and it may contain functions, classes, etc. And it's usually used with modular programming, which is used to separate a program into parts. So here I have my functions module, and inside the functions module, I'm going to have two functions. The first one is function 1, and it's going to basically print this is function 1, and it could do any other thing. It could be a for loop, whatever. But this is just strictly an example. And for our next one, we're going to call it function 2, and it's going to print this is function 2, and please like and subscribe. And inside our main folder, or our main program, we're going to import functions. So at the top, you want to import functions, and from functions you can say import functions as f. This is just to give it an alias, just to make it so that you don't have to write f or functions every time. But for now, I'm just going to keep it as functions just for the example, and we're going to say functions dot function 1. And once we call this function, it's going to print this is function 1. If we do the same thing, but for function 2, it's going to print function 2, or it's going to call function 2, and it's going to do what it says, which is printing this, all of this. Okay, cool. So there's another thing you can do, which is, like I said, the alias. So as f, you can say as f or as whatever. You can give it any name, like that, for example, but we're just going to use f. And when you do that, this way you don't have to write functions dot something something. You can just write f, and that makes it so much simpler, a lot less typing, and as you can see, it has the same effect. Okay, now we did this and we did this, but we can also import specific functions from that module, or specific anything from that module. But in this case, we have functions. So to do that, you just say the same thing, import functions as, or from, from, let me just write that at the beginning, from functions import function 1, and then you can say comma function 2. Actually, when you import the specific function, it's already there, so you don't need to write functions dot something. You can just call the function itself, and same for the second function, and you just call it and it works the same. But this is kind of tedious if you have to do it for a lot of functions. So if you want, you can also say import asterisk or star, as some people might call it. And if you do that, then it imports all the functions and classes or whatever that comes inside this module. And this one is considered kind of dangerous because some might have the same name, or it just might become a little bit too much, and it's going to be kind of confusing when you try to call it inside the code. So it's kind of better to call them specifically one by one, or just not to import all. But as you can see, this works the same exact way. So you can use any of these to import the module and use the functions and classes within that module. And one more thing, you can also type help and pass in modules as the argument, and that will give you all the modules that are in Python from the factory, I guess you could say. And if I run this code, please wait a moment while I gather all available modules, and it'll take a moment, and then it'll print all the modules. And as you can see right here, you have all the modules that you can use, and they're just there from the standard Python library. And as you can see, you have random, which we've used before, and there's also something like math. I'm not sure where it is, but OS, we've used that before with file handling. And you have modules, and you have math, and so on and so forth for all the other ones. But that's basically it for modules in Python. If you liked this video, please like and subscribe for more computer science content, and as always, the full code will be posted in the comments down below. Hello everyone, and welcome back to another Python video. In this video, we're going to start doing one of our first games, and this is going to be a rock, paper, scissors game. So to get started, you're going to want to like and subscribe, because that's the only way the program would run. And after you do that, you want to import random. So we've seen this module before. Random is going to help us pick, or it's going to help the computer pick a random choice between rock, paper, and scissors. And in order to do that, we need to store them inside of a list. So we have, or a tuple, you could say. So we have options, and inside the options, we want to say rock, paper, and scissors. So we have a variable called running, and that variable is going to hold true. So true equals, or running equals true, which means that the program is running or the game is running. And when we want to step out of the game and stop playing it and stop running the program, we want to change it to false, but that's for later in the program. So while running, we're going to store it in a while loop. So while running, so while the loop is, while this is true, basically it's going to keep running. And we want to say player equals none, because the player didn't choose a choice yet. So we're going to store none inside that variable. And the computer, however, is going to have a choice. So we're going to say computer equals random dot choice, and it's going to pick a choice. We're going to pass in our options, and so that it can choose any choice from our options. So it can choose rock, paper, or scissors. Okay, so moving on, we want to say, like, if the player chooses something that's not in the options, we want to give that user a string of text to to tell them that it's not gonna work that way. So we can say while player not in options, which means if the player variable is storing something that's not in options, what do we want to do? We want to say player equals input, and then we can say anything like enter a proper choice. And then this is just us reminding them of the choices. And that's basically it for the, kind of, you could say, the exception. And I messed it up, but yeah. Okay, cool. So then we want to print a statement that tells you what the computer picked and what the player picked. And then we will say if you win or lose depending on the choices. So we're going to use a printf to make things simpler, but you can choose something else, and I could show you later on in the video. But we're going to say player, and here's going to be player, and we want to say, we're going to surround that by quotes, and we're going to say player and then player. So whatever the player picks, it's going to be stored in the player variable, and then here we're going to be inserting the player variable into the string, and it's going to say player colon and whatever the player picked. So here is going to be rock, paper, or scissors. And same thing goes for the computer, of course. So let's just copy that, and here we want to say computer and computer again. Okay, let's check what we have so far. So enter a choice, please, rock, paper, scissors, and let's say that it's going to keep saying it. If we don't enter a choice, it's going to keep saying that. So let's pick a proper choice, and that's rock. So player picks rock, computer picks scissors, and it's going to keep asking you, what do you want? So let's say scissors. Okay, it picked paper and I picked scissors, so technically I won here, and in the first round I won the first round as well, so that's great. So let's close the program and carry on. Now we want to see who wins and who loses, and we're going to do that with the help of if statements. So we're going to say if, and make sure you pay attention to the indentation, because if this if statement was over here, if it wasn't indented, then it would be outside of the while loop, and we don't want that because the while loop is the whole game, basically. So if player equal computer, which means that if we both pick the same thing, we want to print it's a tie. Okay, great. And we can say else if player equal rock and computer equal scissors. So if I pick rock and the computer picks scissors, what's gonna happen then? You tell me. We win, exactly. So print you win. And then we're just gonna copy paste this a few more times, and we're gonna change up the little the words. So okay, so if we pick the same thing, it's a tie, and if we pick rock and the computer picks scissors, we win. Now we want to say if we choose if we choose paper, sorry, and the computer chooses, let's say, rock, then you win again. And if we choose scissors and the computer chooses paper, we win. So these are all the winning scenarios that we have. So rock, paper, or scissors. And if we choose scissors and the computer chooses paper, we win. And then the rest we can just store it within an else statement. So we can say, we can delete all of this and say else print you lose. So this makes things a lot simpler than stating all the cases where we would win and all the cases where we would lose, because if we're not going to win and it's not a tie, then we lose. Then so you don't need to print more or type more else if statements. You can just put else, you lose. And let's try again. So whatever, it keeps asking, we say rock, the computer picked rock as well, so it's a tie. And we can choose paper, and the computer chose scissors, so that's not in any of our winning conditions, so and it's not a tie, so we definitely lost. And you know, so on and so forth. Okay, moving on. Now we want to ask if the player wants to continue playing or not, because this, as you can see, the program runs and runs and runs until I exit out of it manually from here. So how do we fix that? How we fix that is we can say if not input, and then we can prompt the user saying, do you want to play again? So we give it the choices here, Y or N, and that basically implies yes or no. And let me fix that. And then of course dot lower, because if the user has their caps lock on and they put Y, capital Y, we still want it to accept Y, like the normal Y. So equal Y. So if it's not Y, then what do? We say running equals false, because running is true, and while running is true, we're going to keep running this program. So if we set running to false, then it's no longer true, which means the while loop will terminate and it will stop running. And after all of this, you can simply just do whatever you want. You can move on to the next program, or you can just print. So let's try it. Rock, paper, scissors. If we don't enter anything, it just keeps asking. If we enter something stupid, it keeps asking. And if we make a proper choice, as we should, like rock, computer picked rock, or I picked rock, sorry, and computer picked paper, so we lose. And that makes a lot of sense. If we say, let's say Y, then it keeps asking us rock, and it's a tie. Now if we say anything else, it stops. And also, of course, if we say N, or literally anything, like literally anything that's not Y, then the game stops and the loop terminates and the program ends, and it says thanks for playing. And I did say that you can do this another way, and basically the way you can do this is you can basically say for each one, you can say, for example, and this is very tedious of course, but you can say something like this. I'll give you a quick little rundown of it, but you can say if player equal computer, then what happens, we say print computer. I was gonna say computer picked, but we don't need to do that. And then we can say comma computer. And then we can do the same thing for player. And then we can say print tie. And then we can go ahead and say else if player equals rock, and then inside the else if statement we can say if computer equals paper, and then we do the same thing for player, and then we want to print you win or lose. Let me check. Okay, so if the player picks rock and the computer plays paper, then we say you lose. And so on and so forth. As you can see, this is going to be very tedious and very long because we're going to have to check each and every single case, and that could take a lot of time and code to write, so we don't really want that. So you just cancel that and stick to this. But if this works for you and it makes sense to you and it's easier for you to remember or learn, then go ahead and use that. But this is the way I prefer it because it's just a lot simpler. So with that being said, we have reached the end of this video, and if you enjoyed or learned something new, please like and subscribe, and stay tuned for more computer science content. Hello and welcome back to another Python video. In this video we're going to be talking about inheritance in Python. So inheritance allows us to define a class that inherits all the methods and properties from another class. So the other class is also known as the parent class. So think of it as kind of like inheritance, but like with humans, the children always inherit all methods and attributes and properties and things like that of the parents. They don't make their own. So this is also how, or actually they do make their own. They have their own certain attributes and methods, but also they could take some from the parents. So in this video I will explain inheritance in Python. So to get started, we should have a class called vehicle where we will have different vehicles. So class vehicle, and every vehicle should work. So if it works, it's true, and it should have a couple methods as well. So let's define a method called move, and let's define another method called stop. Okay, now that we have two functions, move and stop, we can make these do something, which is, let's say, print this vehicle is moving. And for the next one, we will say the same thing, but stopping. Okay, moving on. Now we should have a couple different vehicles. So right now we have a vehicle class and it works. The vehicle should work and it can move and it can stop since it works. If it doesn't work, then we don't need to worry about it. But okay, next we should have, like I said, other classes. So let's say class car, and this car is a vehicle, so it should inherit from vehicle. That's why we're passing this as an argument. And what do cars do? Cars drive. So that's gonna be our main method or function for the car. And let's say print this car is driving. Okay, and let's make two more classes. Let's make, for example, a submarine. Okay, so I made two more classes. One is a submarine, and it says it has the main function, which is sink, and that function basically just prints out this submarine is sinking. And I have another one that says that is a plane, and it has the main function fly, and when you run it, it says this plane is flying. Okay, so now that we have three classes that all inherit from the class vehicle, we have car, submarine, and plane. So what can we do with this? First of all, you would need to initialize or make objects of the classes. So you can say car with lowercase c equals car with capital C, and then same thing for plane, or let's do submarine first. So here I have made the objects for each of the classes: car for car, submarine for submarine, and plane for plane. Moving on, now we can get to the good stuff. Now we can see how our code or if our code works. So we can say, we can print car dot works. So now we can see if the car works or not. True. Okay, what about plane? Okay, true, the plane works. And what about submarine? Submarine also works. As you can see, all of them are true because works is set to true in the main class, which is vehicle, which is the parent class, and all of these classes, all like these three classes, they inherit from the parent class. So if the parent is true, this is going to be true as well, unless you say otherwise within the class itself. So as you can see, even though the car, submarine, and plane don't have a move and stop method, we can still use these two methods even though they're not in these classes because they inherit from the parent class. So let's do that with a demonstration. We can say car dot move, and if we run it, this vehicle is moving. Same thing for, let's say, plane dot stop. This vehicle is stopping. Okay, cool. Now we can try to see if if these methods work, the ones that are in each of these classes that are the children classes. So we can say car dot drive. Okay, great. We can say plane dot fly. Okay, this plane is flying, that works as well. We can say submarine dot sink, and you can see that works too. But if you try to say car dot sink, that's not going to work. There's no such thing because the car is not going to sink because it's not a submarine and it inherits from the vehicle class, not from the submarine class. So if you watched my last video on object-oriented programming, you can see how you can turn these methods right here. Instead of saying this vehicle is moving, like if you say car.move, instead of saying this vehicle is moving, you can see how you can say this car is moving. And then if you run it for plane, it can say this plane is moving. But you would need to check out my poop video, the Python object-oriented programming video. But that's basically it for inheritance in Python. If you enjoyed this video, please like and subscribe, and stay tuned for more computer science content. And as always, the full code will be posted in the comments down below. Hello everyone, and welcome back to another Python video. In this video, we're going to be talking about Python object-oriented programming, also known as POOP. And basically, object-oriented programming says that each object can have its own set of methods and attributes, and this makes it easy, and each object can be treated almost as a data type, but more on that later. And let's use an example to help you understand. So here we have our own main file, which is the main program, and you can store the objects within the main program, the main file. But if you're going to be dealing with a large file with a lot of different objects and methods, then it's suggested that you make a separate file or module for that and then import it into the main file. So to do that, let's say we want to make objects as cars. So we're going to call it car. Okay, cool. So we're going to say class car with a capital C. And inside this class, we're gonna have our own different attributes and variables and functions, all that stuff for cars, or for any car that we're gonna use. So we can start off with something simple like wheels. So our car should have a minimum of 4 wheels, and this is basically the default. So you can say this is a class variable. Okay, cool. So now we have a function. So we want to define a function, and to define a function, you want to say def, and then this is going to be weird at first, but it'll make sense. INIT, and then double underscores before and after, and self. So let me explain what this means. Init means it's short for initialize, and self means just self. And basically this argument right here, self, kind of tells you that, or tells the program that we're going to be using this class into this. We're going to be initializing this object, which is this class, into this argument, into this function. So this is a function used, I'm sorry if that's very confusing, I'll try to simplify it, but this function is used to initialize self. What's self? Self is the class. And what's the class? The class is the car. As you can see, these are indented, which means they're part of this class, which is car. So this, last time, this function, we're defining a function to initialize self, and you can replace self with basically car in your mind to help you understand. So that's basically it. And what do we want to initialize with this? We want to initialize the make of the car, the model of the car, the year of the car, and color of the car. Okay, so let's initialize all that to none for now. And these are known as instance variables. So these are instance variables right here, the make, model, and year, and color, because these are variables of the instance of the car, which is being initialized over here. And we want to have different methods. So you can say def, and we can have, let's say, a drift method, and we're gonna initialize that to self, because the drift method is for itself, the car. And for now we want to say pass, and we can say define, let's say, drive. Yeah, just drive. Pass. Okay, so now we have the initializing function to initialize an object into the program and into this class, and we have a class variable, which is wheels, which is the default wheels, default amount of wheels I should say, which is 4, and we have 2 methods, and you can add as many methods as you want and as many of these instance variables as you want, but this is purely for just examples. So here we have this method right here, drift, and for the drift method we want to make the car drift. So basically we want to say print this car is drifting, and then drive, we could say print this car is driving. Oops. Great. So we can add on to this, and right now we have this, which is, we'll worry about this later, but we have the make, model, year, and color, and they're not doing anything right now. So how do we fix that? We fix that by, first of all, you want to change the make, or first of all you want to add these. As you can see, this is gray, it's grayed out, so we want to add them into the parameters, and we want to add them into the parameter as arguments so that they can be part of the function. In order to do that, we want to say make, model, year, and color. And now that we passed them in as arguments, we want to use them here. And how do we use them here? We say self dot make, and then again self dot model, self dot year, and self dot color. So now we have self dot color, which means the car itself, the object itself, the make of it. And then same thing with the model and the year and the color. And this will make a lot more sense in a bit, but bear with me. And we want to say the make is equal to the make, model is equal to model, year is equal to year, and color is equal to color. And now we're basically done with this class, with this module, and we can move on to the main program. And this is where the fun begins. This is where we start making our objects. As you can see right now, this is all just very simple and it's very like unknown. Nothing is specified yet. So here is where we start making everything. I completely forgot to import. This is a vital part of the code. If you don't do this, then it's just never gonna work. So we want to say from car, because that's the name of the class or the module. From car, we want to import the class car. So from the module car with the lowercase c, we want to import car, which is the class with an uppercase c. And this is where the fun begins now. So if we run this, it's going to tell you that you're missing 4 positional arguments: the model, the make, model, year, and color. Because as you can see right here, we have the make, model, year, and color, and in order to initialize a car, we need to pass in those variables. So to do that, like I said, we start with a Chevy, and then we want to say Corvette, of course, because it doesn't get any better than that. And we can say 2019, and we can say also the color, so red. Cool. And then we can make another car, but let's just run this, and okay, good, nothing happens, no errors. So let's make another car 2, and let's also use a Chevy, but this time it's going to be a Camaro, because that's just the second best car in the world. And we're gonna say 2014 because I have a 2014 Camaro and it's red, so we'll just change this to black. Okay, cool. Moving on. Now we want to print something. What do we want to print? We want to print the car. What do we want to print of the car? We want to print the car's make. Okay, this is, let's just say car 1 just to specify and make it easier on us. So car 1 make is Chevy. Okay, now we want to say we want to print the rest. So car 1, let's say model, year, and color. So the car's make is Chevy, model is a Corvette, and year is 2019, and the color is black. Great. So now we can do something else. We can say car 1 dot drive. So we're calling the drive method for car 1. Or sorry, not drive, drift. And I pressed enter and it chose just whatever. So we can say car 1 dot drive. And it's drifting and then it starts driving normally. Okay, cool. So now we can do something else. We can say car 1, or we can say car 2 dot wheels, and we can say that equals to 2. Now it's a motorcycle, not a car. And that still works. It didn't give us any errors, so it works. And if we say print car 2 dot wheels, now it's going to tell us how many wheels are in car 2. It's 2. And if we say print car 1 wheels, it's going to say 4, because the default is 4 and we didn't specify anything else, so that's it. So what else can we do? We can do something which is very beautiful, I would say, and we can change it to, instead of saying this car, we can change it to actually saying the car itself, because this is kind of ugly, because when it says this car, you don't know which car it's talking about. So we can change it to something that says this Corvette or this Camaro. How do we do that? It's the same. It's pretty simple. This, and then we want to say, let's close that, plus, and then we want to say self dot model plus is drifting. And let's run this. This Corvette is drifting. Okay, cool, it works. So we want to do the same thing for this. Let me just copy this for simplicity. And this car is driving. So this self dot plus self dot model. So it's telling the car's model. It's calling basically you're just replacing self with car1 or car2 or whatever this right here is, whatever the name of your object is, dot model. So you're calling the model of that specific object, and you want to say is drifting or whatever is left of the print statement. And same thing for here. Basically, like I said, you're just changing from self to the car's or the object's name. So right here we have changed or I added a new car, and it's a wooden sofa. It's 2020 and it's purple. So if we run it, then this sofa is drifting, the sofa is driving, the sofa has 4 wheels, and it's a wooden sofa, and it's 2020 and it is purple. And that's just for jokes, but as you can tell, you can do this with any kind of car or any kind of object, and you can make as many classes and as many modules as you want. So right now this little Python file is a module, and you can import it here, and you can make as many classes in each one. So let's say for car, we can make a class called motorcycle. And within the motorcycle class, we can have literally anything. So that's pretty much it for this Python video. If you enjoyed this video, please like and subscribe. And as always, the full code will be posted in the comments down below. And I'll see you guys in the next one. Hello everyone, welcome back to another Python video. In this video, we're going to be talking about multi-level inheritance. So multi-level inheritance is when a child class inherits from another child class. So think of it as you have a child, and that child inherits from the parent, which is the child of a grandparent. So it's like 3 levels: grandparent, parent, and child. So the child is inheriting from the parent, and the parent inherits from the grandparent. So let's get started with an example. So let's say we have a car class. So class car, and let's say the car is working. So working is set to true. And let's make another class, and let's call it Chevy. And that is going to inherit from the car class, because a Chevy is a car. And we can define a function, so def drive, and we can make this print this car is driving. And we can make one more class so this is the grandparent, this is the parent, and this is the child. But this is also a child of this class. So this is a child of this class, and this is a child of this class. So it's 3 levels. So class Corvette, this is going to be our last class, and it's going to inherit from Chevy, because a Chevy or a Corvette is a Chevy, and a Chevy is a car. So what is this going to do? Let's say define race, let's say, because they're fast, so they can race. And then print this car or this Corvette is fast. And let's try out all these classes. So first, let's make an object of the class. So Corvette equals Corvette. We're going to call the Corvette Corvette. And let's say print Corvette dot. As you can see right here, we have 3. We have working, race, and self. Working is taken from class car. As you can see right here, it's inheriting the working variable from this class, the grandparent. And you have race, drive, which is taken from Chevy, and you have race, which is in its own class. So let's print working, and let's print, or we don't need to print, we can just say Corvette dot drive, and then we can say Corvette dot race, and let's see if they all work. And as you can see, it all works. It's working, true, and it's driving, and it's fast, because if it's a Chevy it works, but if it's a Ford then it's found on road dead. So that's basically it for this Python video. If you enjoyed, please like and subscribe, and stay tuned for more computer science content, and as always the full code will be posted in the comments down below. Hello and welcome back to another video. In this video we're going to be talking about multiple inheritance. Multiple inheritance is not to be confused with multi-level inheritance, because multiple inheritance is when a child class is having more than one parent. So you could say this is multiple inheritance. You have a child class that inherits a little bit from the mom and a little bit from the dad, you could say, from two parents. And multi-level inheritance is a child that inherits from another child class, and this child class inherits from this parent class. So it's like a grandpa, and then a parent, and then a child. So that's the difference between multiple and multi-level inheritance. So let's try an example. So we have class, and let's say prey, and we have a function called flee, and this is gonna print out this animal is fleeing. So we can have another class called predator, and we can define a function called hunt, and we can say print this animal is hunting. So these are going to be the parent classes, and let's have a couple child classes. So let's say we can have a rabbit, a hawk, and a fish. So here we have three classes: rabbit, hawk, and fish. Rabbits don't eat any other animals, so they are considered a prey. Hawks eat rabbits or rats or whatever, like small rodents, so they are considered predators, and no one really eats them, so they're predators. And then you have fish. Fish can be like a large fish, like kind of like a shark, you could say. That can be a predator, but it can also be a very small fish, and that's considered a prey. So as you can see right here, rabbit is the child class of prey, hawk is the child class of predator, and fish has two parent classes. It has prey and predator. This right here is the perfect example of multiple inheritance. So let's try them out. So let's make objects of each class. Now that we have an object of each class, let's try the functions for each one. So we have rabbit dot, as you can see, it has flee only, and if we run it, this animal is fleeing. And you can have hawk, and hawk only has one method. This animal is hunting, because as you can see, hawk, there's nothing here, and it inherits from predator, and if you go to predator, there's only one method, which is this. Same thing for prey, there's only one method, which is this. And if we move on, fish dot, as you can see, fish, it inherits from two, like I said, predator or prey, so it has both functions. So you can say fish.flee, or you can say fish.hunt, and both will work. Let me just cancel these out for like example purposes. And as you can see, when we call the fish.flee or fish.hunt, they both work interchangeably. And that's basically it for multiple inheritance in Python. If you enjoyed this video, please like and subscribe, and as always, the full code will be posted in the comments down below. Hello and welcome back to another Python video. In this video we're going to be talking about method overriding in Python. So method overriding is basically just taking a method from the parent class but overriding it in the child class and making it do something more specific. And I'll show you with an example. So first we can start with a class, and we can say class car, and inside the car class we can define a function called drive. And we want this to print this car is driving. And we can make another class, say for example call it Camaro, and for now let's just write pass, and we can make another class called Mustang, and for now we'll just pass. So let me pass in the car as the parameter of both of these classes, and this way the Camaro and the Mustang will both be the child classes of car. So this is the parent class and these two are the child classes. So let's make an object of each class. So Camaro equals Camaro, and then Mustang equals Mustang. So if we say Camaro dot drive, what would happen? What would happen is it would just print this. And same thing for Mustang. So this is normal inheritance. Now if you want method overriding to be implemented, you have to do two things. One is you have to add in the method, and two, you have to use the same name as the name in the parent class. So just like this, and with the same parameter as well. And now you can say this Camaro is fast, and then if you print it, it will print any method with the same name first, and if there is no method with the same name as the parent class, then it will just use this one. So if you see here, Mustang doesn't have a method called drive, so it just takes it from the parent class. But Camaro has a method called drive, so it doesn't need to go to the parent class, it just calls it from the child class. So that's basically it for method overriding in Python. If you enjoyed this video, please like and subscribe, and I'll see you guys in the next one. As always, the full code will be posted in the comments down below. Hello everyone, and welcome back to another Python video. In this video we're going to be talking about method chaining in Python. So method chaining is basically just calling methods sequentially. So the first method will execute, then the one after, then after, then after, in terms of the order where you order them in, basically, when you're calling them. So for example, I'll teach you this with an example. We have a class routine. So basically this is going to go along with the morning routine of the normal person, and I'll type in the code for each of the functions and I'll get back to you. So now we have 4 functions: wake up, eat, drive, work. So this is gonna print this person is now awake, this person is now eating breakfast, driving to work, this person is now at work and working. So this is all good, but now if we try to call one of the functions like routine. Oh, also I made an object for the class so we can use it. So routine work. So if we run this, you're gonna see that it says this person is now awake, this person is now eating breakfast, driving to work, and at work and working. So if you see, we had to type routine dot before each one, and that could maybe not be beneficial in your case, or maybe you just want them to be one to happen right after the other one, and this isn't good for that. So this is where method chaining comes in handy, and you can do that by deleting that and then say routine dot wake up and then dot drive, and then you run it, but you'll encounter an error. and this is because of the non-type. So basically, when you don't have any return value in a function, Python returns none. And when it returns none, that means it's not a part of the class or object anymore. So that's not good. So to do that, to fix this issue, you want to return self for each and every one. And let me just copy paste this into here. And if we try it again, it should work. Yes, there we go. And dot drive. So you wake up and eat first, then you drive to work, then you work. And this is the routine. And as you can see, they happen sequentially. You wake up, eat, drive, and work. And it gets a bit harder to read if you do it like this, all in one line. So in order to fix that, you can just press enter after each function call, and it will add this. And this is basically like an escape new line character. Basically, like it's telling the code that, you know, just perform this how you would if all of this was on the same line. So it's like as if there's no new line here. So that's basically it for method chaining in Python. I hope you enjoyed this video and learned something new. As always, the full code will be posted in the comments down below, and I'll see you guys in the next one. Hello everyone, and welcome back to another video. In this video, we're going to be talking about the super function in Python. So the super function is used to give access to the methods of a parent class. So it's kind of like a subdivision of inheritance, and it returns a temporary object of a parent class when used. So for example, I have this little piece of code that I've written. We have the parent class, which is rectangle, and then we have two classes that are child classes. One is square, and as you can see, it inherits from the rectangle class, and same with cube, that inherits from the rectangle class. So we have two methods: define init self length width, and then self.length equals length, self.width equals width. Same with here, except that this one also has height, because as you know, to get the volume of a cube, you need the height as well. You can't just use length and width. And for square, you just need the length and width, and you can multiply them together and you get the perimeter. So this is for the perimeter, and this is for the volume. So this is kind of like area and volume. Or sorry, not perimeter, I meant to say area. So this is for the area, this is for the volume. So in order to use the super function, we need to implement a couple things. So to get started, we don't want to reuse this code. We don't want to type it here and then type it again here. What we want to do is we want to do one of each, or just do it one time and use it in each one. So we want to delete this, and again delete it here. And then what? We go to the rectangle class, and within the rectangle class, we want to define init self, and we want to add in the length and of course the width, because it's being used in the square and in the rectangle. But the height is only in the rectangle, in the square and the cube. The height is only used in the cube, so we don't need to write that here. We can just keep it here, write it explicitly. Okay, moving on, we need to define the length and the width. Or not really define, but we need to call it in this function. So self.length is going to be equal to length, and same with width. Self.width equal to width. And we don't need to rewrite this again here and here, because like I said, we're going to be using the super function to access these two. So we're going to do that here. So super, and then parentheses, dot, underscore init, and we're going to say length, and width. This is us basically telling the code, the program, that we want to access the parent class and use these two parameters. And we're going to do the same thing here. And then of course we're going to leave this here like I said because it is not in the parent class. And then to test this out, we want to define two functions. One is going to be the area, the other one is going to be the volume. Area for square and volume for cube. So to get started, of course we need to def, and we would need to say area and self. And how do we do the area mathematically? It's we want to return self dot length times self dot width. And for the volume, it's the same thing, except it's going to be times the height as well. So return, we're going to do it here, def volume self. Oh, it already wrote it for me. And we're going to say return self dot length times self dot width times self dot height. And just like that, it should be ready. And if you want to test it out, we can say print volume, or sorry, cube dot volume, and also print square dot area. So I got this error, and it's basically because I forgot to fix the indentation here, but if we run the code, it should work properly. We have 27 for the volume because 3 times 3 times 3 is 27, and we have 9 for the area because 3 times 3 is 9, and you can play with the numbers as you wish, and it'll still, you know, give you the proper output. But that's basically it for this video. And if you enjoyed this video, please like and subscribe, and as always, the full code will be in the comments down below, and I'll see you guys in the next one. Hello everyone, and welcome back to another video. In this video we're going to be talking about objects as arguments. So we're going to learn how to use objects or pass them in as arguments in functions. So let's say we have a class called man for example purposes, and for now we can set the name to none. And let's have a function called change name. So the man has no name as of now, but we want to pass it in, or we want to change the name, sorry, of the man. So from no name to name, to some kind of name. So we want to pass in a person and the name of that person. And we want this function to say person dot name equals name. So it's going to change the name of that person to another name, or to the new name given. Great. So let's make a man object. So let's say man1 equals man. And let's make two more actually. Okay, and now let's change the name. Let's use the function. So we're going to say change name of man1. So as you can see right now, we're using the object as an argument, and we're going to change the name to, let's say, Mike. And let's see, oh, I forgot to print it. So print man1 dot name Mike. Okay, great. So let's change the names for the other two men. So man2 and man3, let's say man2 will be John, and man 3 will be Yusuf, and print the rest. So man 2 and man 3, and there you go. And if you want to add a different type of class, so for example right now we have a class man, you can do it with another class. So let's say class woman, and name equals to none. And person, this can be literally anything. I'm just using person because it's kind of, you know, more general, but just make sure that this and this are matching. They have to have the same name, the same variable name. And yeah, so woman name equals none, and then we make a woman object. That's kind of ironic. And then we can print woman dot name, and don't worry, I didn't forget to change the name. So change name, we can say, actually as of right now, if we print it, it'll say none. Yeah, it should say none. But if we change it, we can change it to whatever we want. Say for example Lisa. And that's pretty much it for objects as arguments in Python. I hope you enjoyed today's video. If you did, please like and subscribe, and I'll see you guys in the next one. And of course, as always, the full code will be posted in the comments down below. Hello and welcome back to another Python video. In this video we're going to be talking about, or we're going to be making a Python quiz game. So to get started, we need a couple things to set the skeleton of the program. First, we're going to have a tuple of questions, and right now it's empty, of course. And we're going to have a tuple of options, we're going to have a tuple of answers, and then we're going to have a list of our guesses that we make, and we're going to have a score, and it's initialized to 0, and also question numbers, which is also initialized to 0. So to get started, I'm going to fill in the questions and the options and the answers, and I'll get back to you. Okay, so I filled in the questions. The first one is, what is the capital of France? And then the second one is, who wrote the novel 1984? And then, what is the largest ocean on Earth? How many continents are there? And what is the square root of 64? And we have options. The options are A, B, C, or D. And this is a list, or a tuple in a tuple. So this is a tuple itself, and it's inside the big tuple right here. And we have A, B, C, D, A, B, C, D, A, B, C, D for all the questions with its corresponding answer. So, and then we have a tuple of our correct answers. Correct answers. So, for example, what is the capital of France? The first question is going to be C, which is Paris. And then second answer is A, so George Orwell wrote the novel 1984, and so on. So these are all tuples. Why did I choose tuples? Because in Python, tuples cannot be changed, but guesses is a list, and a list can be changed. It's mutable, which means, because right now it's empty, and with each guess that we make within the program, we're going to be appending to this list. So if I make a guess later and it says A, it's going to be added into here. And then if I say B, it's going to be added here, and then so on and so forth. So let's get started with the rest of the program. So first we want to make a for loop, and that's going to contain most of our program. So we're going to say for question in questions. So for each question in questions, what do we want to do? We want to print a dashed line, just so that it's clean and we can differentiate between each question, I should say. And then we want to print the question. Moving on, within this for loop, we're going to make another for loop, and it's going to say for option in options. We want to print, what do we want to print? We want to print the option itself. And of course, we need to add in the list of question num, because we want to add the question number, or add the option for each question number. So for question number 1, we want to add the options for question number 1. For question number 2, we want to add in the options for question number 2, and so on and so forth. So pay attention to the indentation. It's going to be within the outer for loop. We're going to continue, and what we're going to do now is we're going to set up our guesses. So guess is going to be equal to input, and it's going to say enter a guess, and or I should just say enter A, B, C, or D. A, B, C, or D. And that's going to be our guess, and we're going to set it to dot upper, because this function right here will make any of what we input uppercase. So if we input lowercase a, it's going to make it uppercase a, and we do that just because these are all uppercase and we need it to be the correct answer. Because if it's lowercase and these are uppercase, it's going to be incorrect even though the answer is correct. And then we're going to say guesses dot append guess. So we have our list of guesses, and like I said, we're going to append, which append basically means to add at the end of the list. We're going to add the guess. So if I input A, it's going to add A to the end of the list here. And now we want to check if it's correct or not. So if guess equal answers, and then we want to pass in the question num list, because we want to check if the answer for the corresponding question number is correct or not. If it is, we want to say score. If it's equal to it, we want to say score plus equals to 1. And we also want to print out correct. So what this is going to do, as you can see here, score is initialized to 1, so this is going to increase the score to 1, from 0 to 1, and if it's 2, it's going to increase it to 3, and so on. It's just basically going to add 1. Else, because this could be incorrect, so if it is incorrect and it's not equal to the answer, then we want to print incorrect, and then we want to print the actual correct answer with a printf statement that says printf and then answers, and then we want to get the answer for the corresponding question number, so question num, and then is the correct answer. And then outside the else statement, we want to increment the question number just so that we can move on to the next question. So question num plus equals 1. And moving on, this is how we display all the answers and make a guess and, you know, find out if it's correct or not correct. So let's check what we have so far. What is the capital of France? We want to say C, Paris. So as you can see, it says correct, and then it moves on to the next one. So A, and then again correct. The answer here is C, but I'm going to put A just to check. It's going to say incorrect, C is the correct answer. And like I said, C is the correct answer, and so on. So let's move on and try to display the results, because as of right now, we don't know how many we got right and how many we got wrong. We can figure it out since it's a small quiz, but we don't want to do that right now. So, and you know, you can always have a bigger quiz and it's going to be a hassle to figure it out. So we should print, and let's print a dashed line just to separate the two things first, and then let me just remake it here and here, and here we're going to say results. That's not really centered, but I guess it's kind of centered now. And we want to print. What do we want to print? We want to print the answers. And then we want to print the guesses. And then we want to take the score. So answers, and then we want to end the statement with an empty string. So what this is going to do is it's going to keep whatever comes next on the same line. And then we want to say for answer in answers. So for each answer in answers, this is known as a for each loop if you've studied Java before. Print answer, and then we want to end it with a space. So not an empty string, but a space, because now what this will do is just keep what comes next on the same line, which is this. This is what comes next. And what this is going to do is it's going to end each answer with a space. So it's going to be a space, and so on. And then we're basically done here. So let's just print an empty line. And then we want to do the same thing for guesses. So we're going to change this to guesses. And then for guess in guesses, and we want to print the guess. That's basically it. It's the same thing, but with guesses instead of answers. And last but not least, we want to print the percentage. So, or I should say score equals int score divided by the length of questions. So if we have 5 questions, it's going to be divided by 5. We can replace this with just the number 5. This right here, we can just replace it with the number 5. But like I said, if you have more than 5 questions or a lot of questions, it's going to be hassle. And if you add questions, then you're going to have to keep changing this number to however many questions the new amount is. And then we want to multiply it by 100 just to get an accurate percentage. And then print f statement that says how much your score is. So print f your score is, and then score percent. That's basically it. Let's check what we have so far, and if it works, then we're done. What is the capital of France? Let me just make this bigger. What is the capital of France? Let's say C, Paris. Who wrote the novel? I don't know, so I'm just gonna guess C. And it's incorrect. A is the correct answer. What is the largest ocean on Earth? C. Correct. How many continents are there? Let's say A. Let's say 5. Incorrect. C is the correct answer. And what is the square root of 64? Let's say, I'll get this one right, C. And as you can see right here, the answers are C, A, C, C, C. And I guessed C, 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 A, C. So that's why I got 2 wrong, which means it's 60%. So that's basically it for this Python video. If you enjoyed or learned something new, please like and subscribe. And as always, the full code will be posted in the comments down below. Hello and welcome back to another video. In this video, we're going to be talking about duck typing in Python. So duck typing is the concept where the class of an object is less important than the methods / attributes. So class type is not checked if the minimum methods / attributes are present, and it's derived from the famous saying, if it walks like a duck and it quacks like a duck, then it must be a duck. So all of this will make sense with an example. So here I have a small program written. We have a class duck and a class of chicken, and they both have a walk and talk method with different outputs when printed. So this duck is walking, this duck is quacking. And then you have this chicken is walking, and this chicken is clucking. So let's make an example from this. We have class person, and for this person, we want to create a catch method. So def catch, and we want to pass in 2 arguments. One is self, and the other one is going to be duck because we want to catch the ducks. Okay. So then of course we want to say duck dot walk and duck dot talk, and then we want to say print you caught the animal, for example. And then let's just make a duck object and a chicken object. So duck equals duck and chicken equals chicken and person equals person. And then we want to say person dot catch, and we want to catch the chicken. And if we run it, person dot catch, it runs this method and it says the chicken is walking, the chicken is clucking, you caught the animal. So as you can see right here, it says duck, and here it's saying chicken. Why? Because we said we want to catch the chicken, and if it walks like a duck, if it talks like a duck, then it must be a duck. And like it says here, that this is the concept where the class of an object is less important than the methods and attributes. So as you can see right here, the class name is less important than the methods and the attributes, which are walk and talk. These are the methods. So here Python is just checking if it has the walk and talk method. If it does, which chicken does have the walk and talk method, then it just uses this class because the class name is not as important as the methods and the attributes. So the class type is not checked if the minimum methods and attributes are present. So for example, if I remove this right here, if I turn it into a comment and I run this, it'll give me an error because the class type is not checked if minimum methods and attributes are present, but here they are not present because the minimum is these two. And that's basically it for this video. I hope you learned something new. If you did, please like and subscribe, and as always, the full code will be posted in the comments down below.